in electrical engineering department and the course coordinator of this ICT based course which is starting today on the topic embedded C programming of microcontrollers. I welcome you all. We have total 5 nodal centers with us. One by one I'll be connecting and I'll be introducing you to this course, but before that let me have a brief introduction about you, and in case you have some chief guest with you, you can kindly ask him to say a few words. Firstly, I would like to go to NIET Greater Noida, Mr. Anurag Verma. NIET Greater Noida, can you hear me?
Yes ma'am, I can hear you.
Yes.
Ma'am, can we connect after a few minutes with you?
Yeah, sure. I'll come back to you after some time.
For the guest.
Okay. Now we move to the next center, that is Dronacharya Group of Institutions. This is Mr. Ashwini Kumar.
Good morning, ma'am.
Yeah, good morning, sir.
This is Ashwini Kumar from Dronacharya Group of Institutions, Greater Noida. We have got faculty members from CS, IT, Electronics, and a few faculty members even from Mechanical Engineering Department. I would request our director, Professor S.K. Bagga, to kindly introduce himself and the entire and say a few words.
Good morning to all of you. I
Good
am Dr. S.K. Bagga, Director, Dronacharya Group of Institution. Madam, I come to know that you are arranging this embedded C programming and microcontroller through this ICT. It is really a good program and our faculty will be benefited out of this because microcontroller is a very good field that will be used in all equipments, mechanical, electrical, electronics. So I think our faculty will be benefited with this program. Thank you very much.
Thank you, sir. Thank you. Do we have some other speakers, sir?
No, ma'am. Thank you so much.
Okay, thank you. The next center is Meerut Institute of Engineering and Technology.
Hello,
Mr. Abhilash Sharma, can you hear me?
Yes, good morning, ma'am.
Good morning.
Ma'am, thanks a lot.
So we cannot hear you, sorry.
Hello?
Yes, sir, now we can hear you.
Okay, thanks a lot, ma'am, for providing us the opportunity to join the workshop. And presently I am having Dr. A.K. Singh, a very senior professor in CSE department, who is very much interested in microprocessor and other things, embedded systems. So he is our chief guest for today morning. So
Okay.
please, over to him.
Good morning, ma'am.
Good morning, sir.
So this is very nice that we are going to, get this sort of program. So without going to that Chandigarh, without spoiling our time, without spoiling our money, so we are getting a lot of information from your side. So even I attended last programs also. So that was really very nice. So this time also we expect that we are going to get a lot of information from your side. So even this is going to help our final year projects also. So around 20 to 25 participants are there. So I hope for the best. Thank you from my side. Thank you, ma'am.
Thank you, sir.
Thank you, ma'am.
Next center is Dronacharya College of Engineering, Gurgaon. Dr. Vishal Bharti.
Good morning, ma'am.
Good morning, sir.
Ma'am, today we have a chief guest as Professor Dr. Karanjit Singh, Honorable Principal, sir. So over to Principal, sir. Good morning, ma'am.
Good morning, sir.
I'm Dr. Karanjit Singh. I have put in about 29 years in the army, and my association with the embedded C, I would say the C language as such for interfacing of hardware. I was associated in Simulators Development Division, a premier development center in MCME Sikandrabad, that is Military College of EME, where we were associated with the development of driving simulators. Then we had small arms training simulators and all kinds of low-cost training simulators for Army Training Command being developed there.
Okay.
So I got interested in this workshop for just to know that what has changed for all those years, because that was in the year 1999 when I was working on these kind of interfacing projects. So having gone through that, I would like to share with the house the importance of this workshop, where I have managed to pull in about 21 faculties from my college, and from all the disciplines, almost all the 5 disciplines, including mechanical department. So just to introduce that, okay, C language, and while in IIT we were doing assembly level programming, and used to be burning EPROMs and this thing, but there was no ways and means of diagnosing except for some switches or maybe some LEDs. That way, it was a tough time with the pure assembly level programming.
Okay.
So possibly the C language extension committee, they decided to uh, uh, get all the codes together into some common platform and common extensions for C, which is the birth of this embedded C. And the advantages are many. I would say the code is general purpose. It's efficient, small, and portable. Today, even Java virtual machines are there, but they consume a lot of resources. So this is going to be the future, and I'm sure our faculties will go through it and benefit the most from this workshop. Thank you, one.
Thank you, sir. That was really nice to hear from you, and I think we will also learn a lot from your experience. I mean, it's really nice to know that you've worked so much on embedded C programming and real-time simulators and all. Thank you so much. Next, we move to MMU Mulana. Mr. Vikas Verma. उनको पता है कि इस समय आई थिंक दे आर नॉट हैप्पी बोला हुआ है. Can we move to NIT Greater Noida? NIT Greater Noida. Mr.
Hello.
Anurag Verma.
Ma'am, just 5 minutes more.
Okay. In the meanwhile, we have some participants here also. आपके साथ जो बाकी के वो आए नहीं अभी तक. अच्छा. So we have one participant here also. Let us hear from him also. Deepika?
Good morning, everybody. My name is Rakesh Gupta. I'm from Ramtech family. I'm the assistant professor in Department of Electrical and Electronics Engineering. And my work is working on the system. So thank you for this opportunity.
So in the meanwhile, I'll give you some glimpses about what all we are going to cover in this course. You must already be having a copy of the timetable with you. As you can see that firstly we'll be having an introduction to the microprocessors and microcontrollers, which will be taken by me today. And architecture of 8051 will be discussed by Dr. Baban Kumar. He's a senior scientist in CSIU. And tomorrow we'll be starting with the various programming languages which are used for microcontrollers, and then we'll be specifically coming to the C programming of 8051, how it is advantageous over other languages. And then in the afternoon session, because in the morning we'll already be having some idea about how to program a controller in C, and some programs we'll be having. In this practice task, as you can see in the timetable, what I'm going to do is I'm going to give you some problems, and then we'll be discussing those problems and you will be attempting them on your own, and after some time then we will be discussing those problems. And on 4th, that is on Wednesday, we'll be having a session again on circuit simulations using Proteus software. See, once we know the hardware of a microcontroller, once we know how to program a microcontroller, so once we know how to program a microcontroller using a C, then before actually developing any hardware program, it is very important to do the simulations first, because we have the program with us and we know how to make the hardware. But before actually making the hardware, it is always advisable to firstly do the simulation part, so as to see that if our code is working fine, or if there is any problem in our hardware. So keeping that particular thing in mind, I have kept 2 sessions on Proteus software, which is very widely used for the circuit simulations. And again, in the afternoon on Wednesday, there will be one industrial applications of microcontroller. Again, session by Dr. Baban Kumar, who will be discussing with you his experiences about all the projects they make, these scientists make based on microcontrollers, and how they make use of this languages and what all applications are there. All those parts will be covered there. And on Thursday, again, there will be sessions by me, wherein, see, once you have made the program in C, then how to create the hex file, that is by using the Keel software, and then how to burn it into a chip, either by using a universal programmer or we use some kits. So that session will be taken up by me, and again we'll be discussing some more programs on embedded C as well. And in the afternoon on Thursday, we have one session by Dr. Chatterjee, that is speed control of DC motor using the microprocessors. This is again one application part. And on Friday, there will be a session on C programming of 8051. Apart from this, I have also kept one session by one of our ME students who has developed a robotic application using C language. So around 11:30 onwards, maybe Mr. Alokdeep Sharma, he's our ME students. So he will be telling you about the robotic application he has developed based on this C language. So that is all about this course. Actually, I'm waiting for my HOD, Dr. Mrs. Lini Matthew. She's on the way. She'd gone for some work and she's on the way. So by the time she comes, let us again go back to the center. Mulana has got connected. Okay. MMU Mulana.
Yeah. I'm Dr. S.K. Agarwal speaking from...
Hanji sir, good morning.
Good morning, ma'am. How are you?
I'm good, sir.
Okay. First of all, I would like to thank Electrical Engineering Department, NIT Chandigarh, for organizing this course. And embedded C is very important if some students want to understand what microcontrollers are. And it is at the backbone of, microcontrollers are now at the backbone of automation industry. So it is very important for the faculty members and students to understand this particular concept, to understand programming language very clearly, so that they can have a future in automation industry. Once again, I would like to thank your whole department for organizing this course and our faculty, and I'm also very hopeful that our faculty and students will be immensely benefited from this course. Thank you.
Okay, sir. So here I would like to tell all the centers that in case your students want to attend and they want to attend some of the sessions, so they can attend these sessions in case some of the topics are relevant to the students. Now coming back to our first center, NIT Greater Noida, Mr. Anurag Verma.
Hello.
Yes, sir.
Good morning, ma'am.
Good morning, sir.
We are having around 50 participants with us, and last time also we have attended the workshop on MATLAB, and we have with us our chief guest, our director, Dr. Ajay Kumar. I would like to say a few words. Sir, please.
Good morning to you all.
Good morning, sir.
Madam, actually at NIT we are conducting this third FDP on embedded C programming of microcontrollers, and I'm thankful to NITTR Chandigarh and Professor Punia also. Actually, from the last 1.5 years we have connected to NITTR Chandigarh, and through this ICT scheme we have trained our approximately 100 faculty members. And my mission is just to train all the faculty members. In 1 year, they should get at least one FDP certificate from NITT Chandigarh. So through this scheme, ICT or maybe different schemes, actually they will enhance their technical knowledge, and finally our students will be benefited. So again, I'm thankful to NITTR Chandigarh and Professor Punia. Wish you all the best. Thank you very much, madam.
Thank you, sir. So, thank you, sir. So, as I told you that I'm waiting for my HOD to come, she has not yet arrived. In the meanwhile, in case you have any doubts or you want to discuss anything or you want to ask anything about this course or anything, then you're most welcome. Can you connect one center at a time? Yes. In case you want to ask anything from your side. Yeah, one more thing. I would request all the centers to kindly download Keel software. Keel software, because all the programs which we are going to discuss here, it will be really nice if you will be able to create hex file using the Keel software. I will email the link of Keel to all the course coordinators on the email IDs provided by you. So kindly download that software and provide it to all the participants. Do we have a net here? Like, abhi main mail bhej deti hu. So initially you can download the evaluation version. हाँ अर्जुन मैं अभी कोर्स में हूँ अभी तो ये कोर्स का वो एक्चुअली इंट्रोडक्शन चल रहा है इन ऑर्गेनाइजेशन इसको म्यूट करूँ हाँ 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 करवा दो Srini ma'am, to please kindly say a few words. We've been waiting for you.
Good morning to all of you. How many centers?
5 centers.
5 centers. The participants at the different centers. I'm so sorry. I had a meeting with our director, so I had to go there. I think Ritula might have given you the introduction to the course, the contents of the course. This will be a very useful program, embedded C programming of microcontrollers, and I think she had called some experts also, Tejinder, and I hope that it will be very useful for you, and I request all of you to attend all the sessions. That is very important. All the programming classes which she will be taking, all the detailed classes, which the practical classes which will be happening here. So I wish all of you a good time of study throughout this week. Thank you very much.
Thank you, ma'am.
So what are you planning now for a tea break?
Yeah, tea break. Actually, the first class is scheduled for 11:30. So I said that all of us will reassemble at 11:30 sharp.
Sharp. Okay? Good.
Thank you.
45.
Excuse me, ma'am.
Yes, sir.
Ma'am, Abhilash here. Ma'am, do we need embedded system kits?
No, you don't require embedded system kits as such, because every center will be having different different kits.
Okay, ma'am.
But in case you want to have some, because on Thursday I am planning, when Keel Software and Universal Programmer session is there, I am planning to show you some kits which we have and practical demonstration on that. So in case you want, you can keep with them with you, but the thing is the same, the procedure is the same.
Okay.
You want to practice the programs, because it will be the same, like LED connection, LCD connections and all these things. So they are on all the kits, I suppose.
Okay,
So
one more
programs
thing.
I'm going to discuss.
Okay. One more thing, ma'am. The Keel software, ma'am, ये क्या Unix पे भी support होगा, Linux environment पे?
होता है इसका, लेकिन ID Windows के लिए बेस्ट है.
Okay. ठीक है
तो
मैम.
आप Windows पे कीजिए इसको, because मैंने Linux पे कभी ट्राई किया नहीं है.
Okay, ma'am, which version?
Microvision 4 is the latest one.
Okay, so it's freely available?
Yeah, it is freely available. I was just trying to download it, but because of some problem, it's not getting installed here. In the meanwhile, I'll try that in this tea break. If I go to my room, I have with me, but I'll have to zip it and send it to all of you. But what you can do is that go to www.keil.com.
Okay, ma'am.
And therein install, you'll get various versions, like Keel is there for all the microcontrollers, but since in this particular program we are mainly going to study embedded C for 8051 microcontroller, so kindly install it for C51.
C51?
C51, yes, the evaluation version.
Okay, ma'am.
Evaluation version has got some like limitations, like 2K of file is only supported, but that is enough for our programs which we are going to discuss in this STC.
Ma'am, one session is on Micro C.
Micro C?
Mu C.
Microcontroller. Actually, that is microcontroller. That's short form for microcontroller.
Okay.
Industrial applications of microcontroller on Wednesday you are talking now?
Yes. Where does it?
UC is actually short form of microcontrollers.
Okay, ma'am.
Anything else? Anyone else wants to ask anything?
Ma'am, on Tuesday, 11:30 session is there on C programming of 8051.
Yes,
so,
sir.
ma'am, normal C compiler, turbo or Borland or?
Keel compiler is the one.
Compiler. Okay, ma'am.
Compiler.
Fine. So we will download it.
Yeah. That's why I'm saying that all the programs which we are going to discuss in this STC, kindly download the Keel version, because ultimately what you have to burn into the controller is the hex file. Whether we learn C, whether we learn assembly, anything, ultimately it is the machine file.
Okay, ma'am, one more query. Ma'am,
Yes.
क्या chip burning की अगर बात करेंगे तो उसके लिए कोई support?
चिप बर्निंग की बात करेंगे तो उसके लिए सर 2 चीजें होती हैं, एक इन सिस्टम प्रोग्रामिंग होती है और एक होता है हमारा यूनिवर्सल प्रोग्रामर.
Okay, ma'am.
तो वो सेशन मैं आपका थर्सडे को लूंगी. Then I'll tell you the details of how to burn our controller into the programmer, into your microcontroller.
So, ma'am, do we need any kit for that thing or? Okay.
No. Fine. I'll be demonstrating from here only.
Okay. Thank you, ma'am. Thanks a lot.
Anyone else? So, okay. Thank you. Please So shall we start? All the centers are here. Okay, welcome back all of you. We have come to our first lecture, that is Introduction to Microprocessors and Microcontrollers. And because before we do any kind of programming, it is very important to understand the hardware part of any controller. We should be well conversant with the pin diagram, the block diagram of any controller before programming it. See, there are two parts in an embedded systems. One is the hardware, the other is the software. So initially we need to understand that before going to the 8051 microcontroller, what is the basic difference between a microprocessor and a microcontroller? Can any one of you explain?
This microprocessor does not have any other things, any peripheral, just one type of CPU. And microcontroller have all kind of peripherals, CPU, RAM, phone, timer, clock. Microcontroller is a computer on a chip.
Right.
It has internal memory, RAM, phone, timers, peripherals, and important ports, other things. But in microprocessor, the micro interface is also like RAM, ROM, IOs. It is not very good.
So for those who have worked on microcontroller are very well aware of the difference between a microprocessor and a microcontroller. But if a layman is asked what is a microcontroller, we need to understand the concept of microcontroller from beginning. Like we all are very well aware of what a CPU does. CPU of a computer. See, CPU is nothing but central processing unit, and it basically processes the information which is given to it through our input devices, and it processes those instructions, either they are instructions or data, and it stores the result either in its memory or it displays it in some display device. So that is the work of a CPU. But if we are able to put that CPU on a single chip, that is nothing but a microprocessor. So as I said, in a layman's language, we can say that a microprocessor is nothing but a CPU on a chip. However, a microprocessor alone cannot work. It's not a standalone system because you need to attach some peripherals to it. You need to attach input-output devices to it. Why do we require to attach those input-output ports? Because in order to real-world interface the things like LCD, keyboard, or any sensors or output device, some actuators, relays, etc., you need some input-output ports, which my microprocessor does not have. So because of that, you need to attach 8255 programmable peripheral interface chip to a microprocessor. Apart from this, a microprocessor does not have any memory of its own in order to store the data and the instructions. So you need to attach the external memory, that is RAM, ROM, to the microprocessor. Then for timing and counting purposes, you need to externally attach the timers and counters to it. And then for serial data communication, serial port also you need to externally attach. So this whole makes it a complete microprocessor system. But what was our main aim? When we were wanting to make the CPU on a single chip itself, what was our main aim? To make it a compact system. But now when we have to externally attach all these things to a microprocessor, it becomes bulky, it becomes costly. So the engineers thought that why not make another chip in which all these peripherals are also in it also, and that is nothing but a microcontroller. So main difference between a microprocessor and a microcontroller is that, in simple language, if a microprocessor is a CPU on a chip, a microcontroller is nothing but a computer on chip. So this is the basic difference between a microprocessor and a microcontroller. A microcontroller has got its own ports, input output ports. You need not externally attach any kind of PPI chip to it. Microcontroller has got on-chip memory with it, so you need not attach RAM-ROM to it. A microcontroller has got timers, counters in itself, so you need not attach anything. And then it has got serial port itself, so you need not attach. But can you think of any advantage of a microprocessor over microcontroller?
Microprocessor has flexibility.
Hmm.
Like we can interface external RAM to any size, any one size. But in microcontroller, it is fixed.
It is fixed.
Yeah.
Because, very rightly said,
Yes.
because what is happening is that a microcontroller has got on-chip memory. You have got a fixed amount of memory, you have got a fixed amount of input-output ports, you have got fixed amount of timers, counters. Although yes, externally we can attach it to that also, but अगर हम उसकी अपने microcontroller के architecture की बात करें तो आपको on-chip RAM के साथ ही काम चलाना पड़ेगा. But in case of a microprocessor, the programmer or the person who is working on it has got the versatility, he has got the flexibility to attach external memory. Amount of memory, of course, it depends upon certain factors. It's not that we can keep on adding any amount of memory to it, but yes, of course, according to our application, we can attach amount of memory to it, and so we've got the versatility to it. Another important difference is that a microprocessor is a general purpose, whereas a microcontroller is a dedicated. Suppose you want to design some application which has got let's say a microwave. A microwave's purpose or its work is to heat the food. So that is one application for which it is meant for. So there we would, in such applications wherein there is a dedicated single task itself, we prefer to use a microcontroller over a microprocessor. I hope I'm clear about the basic difference between a microprocessor and a microcontroller. So whatever I said is clear from this diagram. In the form of figure, we can see that a microprocessor is a general purpose microprocessor in which you need to externally attach the memory, you need to externally attach the input output ports, timers, serial COM port, whereas in case of a microcontroller, all these peripherals are on a single chip itself. So what is the advantage? Advantage is the biggest advantage is in the form of cost. Because in any application wherein large amount of units are to be made, cost matters a lot. You can get a microcontroller for as low as 50 rupees in the market. And another advantage is in the form of compactness. Because on a single chip itself, you have got all the peripherals attached, so it is very compact in size. Then power consumption is also low as compared to a microprocessor. However, if we talk about versatility or flexibility, of course, that is more in case of a microprocessor. And a microcontroller is dedicated, whereas a microcontroller is dedicated, whereas a microprocessor is more used in case of general purpose applications. So these are some of the applications wherein we use microcontrollers. These are everywhere in your home, all your appliances, in your TV, cable TV, computers, VCR, remote controls, video games, cell phones, instruments, camera, sewing machines, toys, exercise equipment. In fact, though we may not be aware of what a microcontroller is, but most of us are using microcontrollers in our daily life. Then there are applications in office also. Everywhere we have these applications. Now the next question is how to choose a microcontroller. How do we choose a microcontroller?
Well, it depends on application.
Application, that is most important. It is application specific. So what all factors do you think?
How many bits?
नहीं, वो आप कैसे डिसाइड क्या सोच के करते हो कि मुझे इतने बिट का माइक्रो कंट्रोलर लेना है?
Requirement of bit size, RAM, ROM, and flexibility, heat sinking, speed, number of peripherals it can accommodate, and it can externally interface with number of IO pins, and cost, availability, and then is upgradation.
Upgradation, very good. Now let us move to the various centers also. Let us hear it from you. So my question basically is that whenever we are, see, there are a lot of controllers which are available in the market. In fact, Intel was the pioneer, which started with microcontroller, and then slowly in industry it was flooded with various other companies as well. So Intel gave its copyrights to the other companies, saying that the basic core should remain the same. So you can develop microcontroller of your own, but the basic core should remain the same. Was this condition? So now when we have got so many controllers available in the market, what factors do we have to keep in mind while choosing a particular microcontroller? So can you think of any factors? Let us hear from our centers. Firstly, NIT Greater Noida. Yes, sir. Can anyone answer? आप क्या चीजें अपने दिमाग में रखते हैं सोचते हुए, मतलब कोई भी कंट्रोलर को चूज करते वक्त?
Ma'am, I think first objective is to see the application. So
Yes.
depending upon the application, we can decide. If it is very simple application, we can do it with 8051. If it is a complicated, then we can go for the higher processors.
Okay. And
Memory size also matters. If the program is too large, and
Yes.
speed also. So all these factors matter in selecting the processor.
right. Some other center wants to answer.
Hello. Yes.
Yes.
This is Varun Singhal from MIT Merit.
MIT
I would
Merit.
yes. I would like to add 2 points that skills of the designer also matters, and second one is peripherals in the microcontroller.
Okay. Skills of the programmer. I mean, can you elaborate on that?
Like if I know I have the knowledge of 8051, then I'll prefer some 8051 family microcontroller.
Right.
Or if I have some knowledge of ARM or someone else, then I'll prefer from that family.
Okay. Okay. Some other center would like to answer. एक चीज मैं सुनना चाह रही हूँ जो अभी तक मुझे मिला नहीं सुनने को. कॉस्ट के बारे में नहीं किसी ने कहा. See, cost बहुत important है. Whenever you are developing any application, then you have to think, like, for example, I want to make an application which should cost only 200 rupees. So, because say I am an industrialist and I have to make around 1 lakh units of any particular toy, and my main requirement is that each cost should not be more than 200 rupees. So the developer will not think that yes, I have worked on a very advanced microcontroller, so I should go for a controller which costs me around 1500. So he would naturally want to use a controller which is low cost so that he can make the particular application in that particular requirement only. Then of course speed matters. Now speed, suppose you have any application wherein time is very critical, so accordingly you will choose a controller which is fast. Packaging important, like your application, it should be compact, it should not occupy much of the space, it should be SMT mounted. Power consumption is also important. Suppose you want to make your application which is in a field, you are using a battery. In that case, of course you will choose a controller which has got less power consumption. Then memory, as some of you pointed out, it is also very important. Depends upon how large my program is. Suppose your program is it's not a very big size, so definitely you would want to go for a controller which has got a small amount of memory. Input output pins, why they are important is that depends upon how many peripherals you want to attach to your controller. Accordingly you would want to use a controller which has got those amount of input output pins. Timers for timings, yes, of course. Upgradation to high performance, we have to see future also, that in future if you want to upgrade to another high performance, is there any upgrade available of that particular upgrade version available? Then cost, as I told you. Apart from this, these are all the computing needs. Apart from these, you need to have software development tools also available to you. आपने अपना हार्डवेयर तो बना लिया, but ultimately तो आपको अपना प्रोग्राम लिखना है, प्रोग्राम को बर्न करना है. So for that particular controller, are you having those software development tools available with you? Like assembler, debugger, compiler, etc. So all these points you have to keep in mind. Then of course availability and source, it should be readily available in the market. ये नहीं है कि हमारा controller खराब हो गया और वो availability उसकी नहीं है. So all these things you must keep in mind while choosing a particular microcontroller. Support, technical support should be there. Yes, वो लिखा है सॉफ्टवेयर डेवलपमेंट टूल्स में ना, टेक्निकल सपोर्ट भी आपको मिलना होना चाहिए उसका. नाउ एज आई टोल्ड यू, थोड़ा सा डिले क्यों होता है नेटवर्क की वजह से. So another thing is that what are the various companies which are available? As I told you that Intel is the pioneer, which initially started with microprocessors in 1971. At that time, 4-bit microprocessor 4004 was introduced, and then gradually higher versions of the microprocessors came into picture. Then in 1980s, microcontroller was launched in the market. Then there are many other companies which are available like Atmel, Philips, Siemens, Dallas Semiconductor, etc. But the core remains the same. It is very important to understand that the core of all the controllers is that, because Intel had given its rights to the other companies with this condition that your basic core architecture should not change much. So what are the various additions which you can have in the controller? As for example, you can have more amount of memory, you can have different types of memory, you can have more timers, more counters for the speed, clock speed, etc. And then you can have ADC on inbuilt also. ISB programming. Now, what is the significance of this A to D converter? As I said, significance. हमें A to D converter क्यों चाहिए यहाँ पे?
Because all the physical parameter of sensors and transducers they give us analog. And we need to process it to control our processor. This is a mystery.
Yes, because microcontroller works on digital. It understands only zeros and ones. It doesn't understand our language. ठीक है. और लेकिन आपके जितने भी real world sensors हैं, all of them are analog in form. For example, if I have to control the temperature of this room, so temperature का जो data आपको temperature sensor के through मिलेगा, that will be an analog in nature. But you have to convert it into digital form with the help of an A to D converter. And there are some versions available of microcontroller in which you have A to D converter inbuilt itself. So you don't have to externally attach any A to D converter. Similarly, D to A converter also, because when you have to, आपको फिर वो data को जब real world में भेजना, you again require an analog form. So you need not. So some controllers are available which have got inbuilt D to A converter as well. So this is the core of microcontroller which was introduced by Intel in 1981. As you can see from here, this is the CPU. A microprocessor, that means a microcontroller has got a microprocessor as its heart. It basically processes all the information which is provided to it, and then there is bus control signals, and there are 4 input-output ports, as you can see from here. So these are for the real world interfacing parts. So 4 ports are, each port has got 8 input-output pins. So maybe in the afternoon, if I have some time in this session, I will be introducing to you the pin diagram of 8051 in this session itself, or else this part will be covered by our expert in the afternoon session. Then for the serial word interfacing, you have one serial port also, in which there are 2 pins, RxD and TxD. RxD is for receiving the data serially, and TxD is for transmitting the data serially. Then you have 2 timers for timing and counting purposes. These are 2 16-bit timers. Then we have on-chip RAM. RAM is basically the data memory, and ROM is the program memory. And then we have interrupt controls also. And very important, another part is this oscillator circuit, as you can see from here. This oscillator circuit is very important because just like we human beings require heartbeat in order to remain alive, a microprocessor requires pulses to work. In case you don't provide it the right amount of frequency, microcontroller will not work. So those pulses are provided by this oscillator circuit. Now this is another important difference between a microprocessor and a microcontroller, that in case of a microprocessor, whatever frequency you want it to work on, you have to provide it with a double frequency. For example, आपको microprocessor ने 3 MHz पे काम करना है, तो आपको उसको 6 MHz की frequency देनी पड़ेगी, because internally its architecture divides that frequency by 2. However, in case of a microcontroller, whatever frequency you want it to work for, you will have to provide that particular amount of crystal oscillator. For example, A microcontroller's frequency range is from 4 megahertz to 30 megahertz. 4 megahertz से लेके 30 megahertz के बीच में it works, and the most widely used frequency is 11.0592 megahertz. A very typical सा figure है, क्यों? Baud rate compatibility, because आपने जो programming करनी है अपने IBM PC से, उसकी baud rate compatibility with the controller is the best at 11.0592 megahertz. So अगर आपको इस पर्टिकुलर फ्रीक्वेंसी पे काम करवाना है तो ये जो आपका ऑसिलेटर सर्किट है, इसके यहाँ पे आपको ये क्रिस्टल दिखाई दे रहा है. सो ये क्रिस्टल, इट्स वैल्यू शुड बी द सेम, एंड देन देयर आर 2 कैपेसिटर्स आल्सो. So this is the oscillator circuit. You will be studying more detail of this in the second half when you do the architecture part. Now, the core 8051, basically it has got 4K of ROM, it has got 128 bytes of RAM, there are 2 timers, 32 input output pins. Now why we have 32 input output pins? Because there are basically 4 ports and each port has got 8 input output pins, and there is 1 serial port and 6 interrupt sources. Its higher version, that is 8052, has got double the memory, that is 8K ROM, 256 bytes of RAM. There are 3 timers and there are 8 interrupt sources. Then there is also another microcontroller which is known as ROM-less microcontroller. It has got rest of the features. If you see 8031 has got rest of the features are same as 8051, with the only exception that it has got 0 ROM. आपको उसमें external memory जो है वो लगानी पड़ेगी. Now, various 8051 microcontrollers, as I told you, one very important difference in various version of the microcontroller is the amount or the type of memory it has got. Like 8751 microcontroller, it has got UV EPROM. UV EPROM क्या होता है कि इसमें जो आपका जो memory है, that is erasable with the help of a UV rays. So आजकल तो I don't think anyone uses this 8751. Almost 10 to 15 years back we had used this. So it used to contain one window. एक window होती थी और हम क्या करते थे कि उसको जो प्रोग्रामर होता था हमारा UV प्रोग्रामर उसमें रखते थे, and UV rays के through around 20 to 30 minutes लगते थे पुराना प्रोग्राम erase होने में, and then you used to again reprogram it and then used to test it. But it was very time consuming. Every time you have to take it out, you have to put it in the UV programmer. It takes around 30 minutes to erase. So it was very time consuming. So nowadays 89 series जो है आपकी, like for example 8089C51, it has got flash memory. Flash memory means in system programming ही आपका, you need not take out your controller from your board. आप उसी को ही directly अपने computer के साथ लगाइए and you program it in that way, at that time only. I am going to take some demonstrations of this controller in my class on Thursday. When we'll be studying this Keel software and universal programmer, I'll be showing you some kits wherein I will be programming my controller 89 series controller with the help of in-system programming. So it has got flash memory. Then there is DS5000 Dallas semiconductor. So it has got NVRAM. NVRAM is basically 1 byte at a time आप उसकी programming भी कर सकते हो. Then there is one-time programmable version of 8051. Can you think of why do we require this one-time programmable version? One-time programmable तो basically उसको आप erase भी नहीं कर सकते हो. So कहाँ पे use करेंगे हम one-time programmer?
एप्लीकेशन जहाँ पे यूजर से प्रोग्राम ना कर सके,
यूजर उसको प्रोग्राम ना कर सके, या फिर हम ये भी कह सकते हैं कि हम सिक्योरिटी पर्पस के लिए प्रोग्राम कर लिया तो कोई उसको चेंज ना कर सके. एक और चीज हम ये सोच सकते हैं कि हमारी टेस्टिंग
final product
हेलो yes
in the final product we should use one time programmable.
Yeah, exactly. That is what I'm saying. See, during your testing program you can use some other controller, but in your final product, when you are sure that your code is working fine in that particular, you can make use of this one-time programmable, that is ROM version. Then coming to okay, then coming to the various programming languages of controller. See, basically, Deepika यहाँ board नहीं लग सकता. कहाँ पे? अच्छा चलो अभी मैं फिर ऐसे ही बता देती हूँ. It will take some time. Next में लगा देना because I would need, कल तो मुझे चाहिए होगा बोर्ड प्रोग्रामिंग करवाते वक्त. Okay. Now when we are talking about the programming of any controller, then it is very important to understand firstly what are the various programming languages of controllers. See, controller initially जो programming हमारी शुरू हुई थी, that was machine language, because as I told you, a microcontroller does not understand anything else. It understands only zeros and ones. So zeros and ones means it understands only machine language. However, it was very cumbersome to write your program in a machine language. तो zeros and ones के form में एक तो program cumbersome भी है, lengthy भी बहुत ज़्यादा हो जाता है. So programmers they came up with assembly language. Assembly language क्या होता है? It uses English like words which are known as mnemonics. For example, move, add, jump, etc. So these mnemonics are basically used for your convenience. You write your program in assembly language, but ultimately the controller is not going to understand even a bit of the assembly language. You have to translate that into hex file. Hex file means again into machine language. And that how do? You use some assembler. So assembler is nothing but a simple program only. Assembler is a set of program which is used to convert your assembly language into your hex language. Now, although it is very easy as compared to a machine language that you are writing your program in assembly language, however, assembly has got one disadvantage. The disadvantage is that it is machine specific. I am working on one particular microcontroller. मुझे उसका hardware समझना पड़ेगा, उसके mnemonics समझने पड़ेंगे. Suppose if tomorrow I want to migrate to some other controller, I cannot use the same mnemonics. I cannot use the same hardware. I have to understand or I have to learn the architecture of the other controller as well as, and I have to understand the machine language instructions of those particular controller also. So this is the disadvantage of the assembly language program. That means it is machine specific. So what to do? इस इन disadvantages को overcome करने के लिए high level language जो है वो उसका इजाज हुआ, उसका it was formed like high level languages, for example your C, C++, basic, COBOL, etc. And these had got all the advantages over the disadvantages of assembly language programming. And the most widely used programming languages in industry is C, of course, embedded C, which is the theme of this FDP also. So embedded C is the most widely used programming language and it has got various advantages. The biggest advantage is that it is portable. I mean, it is not machine specific. You write your program and it will work for others also. Then there are other advantages also. It is easier to write your program in C as compared to assembly language. Your program size will be small, because whereas in case of assembly language you need to use at least 4 to 5 instructions, for C you need to use only 1 instruction, so your total overall size will be small. Then there are some already built-in functions which you can use in case of C. That is another advantage. It is easier to troubleshoot, it is easier to write your program in C language, and that is what we are going to cover today also. But before that, it is important to understand that what are the registers or general purpose registers on which 8051 works on, because these registers are also used while you are doing your programming. So as I told you that 8051, yeah, we didn't discuss the concept of data bus and yeah, because in this class it's a very basic class wherein we will be having a basic idea about any controller, what all things you must keep in mind. Now, as we saw that initial microprocessor which was launched in the market was 4-bit microprocessor by Intel, that is 4004. It was launched in 1971, and then came 8085, 8086, then your 80186, 80286, 386, 486, then Pentium, Pentium Pro, etc. So what was there which was changing in all these processors? स्पीड तो ऑफ कोर्स बढ़ रही थी, लेकिन वो क्या फैक्टर था जो इस स्पीड को बढ़ा रहा था? नंबर ऑफ ट्रांजिस्टर इज बेसिकली आपका साइज, आपका साइज कॉम्पैक्ट हो रहा है, आप जितना ज्यादा क्राउडिंग ऑफ ट्रांजिस्टर्स को कर रहे हो.
Ma'am, I'm
Yes.
Dr. Ajay Kumar Singh. Is it L1 L2 cache memory that is embedded along with the processor nowadays?
Pardon, sir?
Is it L1 L2 cache memory that is already embedded nowadays in processor
No, what
for increasing the speed?
Yeah, of course ये memory and all तो है, but ये जैसे अगर हम एक बात कर रहे हैं 4004 की या 8085 की, 8086, 80186 Pentium Pro, तो मेनली इनमें जो जैसे हमारे पार्टिसिपेंट ने आंसर किया कि स्पीड बढ़ गई, बट स्पीड किसकी वजह से बढ़ गई?
The number of bits it can process at the same time, that is 8 bit, then 16, then 64 at the same time.
Yes. So what is that which is increasing? वो number of bits किस पे depend करती है?
Accumulator width.
Size of its data bus.
And accumulator width.
Accumulator is also, yeah, actually what is happening is that whenever you are saying that it is an 8-bit microprocessor or it's an 8-bit microcontroller, then there are two things which are 8-bit in it. One is the size of its data bus, the other is the size of its general purpose registers. That is why I am discussing this, because now when we want to see what are the various general purpose registers, if we are saying it is 8-bit or it is 16-bit, that how does it matter? For example, for those who are new to the world of microprocessors and microcontroller, I would like to give you a very simple example of the difference in an 8-bit microprocessor or a 16-bit microprocessor or a controller in that case. When we say that it is an 8-bit microprocessor, that means the size of its data bus is 8-bit in size. Now, how does that affect the speed? For example, if I have to process one 8-bit data, and I am using a controller or a processor which has got 8-bit data bus, then that controller can process those 8 bits in one cycle at a time. Suppose I have to process 16 bits of data, then the same processor will take how many cycles? It will take 2 cycles at that time. But if I use a 16-bit microprocessor, it will take only a single cycle to process that single 16-bit data. So the speed increases. अगर मुझे एक लेमैन को ये चीज सिखानी है, बताना है, सपोज आपको जिसको कुछ नहीं पता है कि डेटा बस क्या होती है, स्पीड कैसे बढ़ रही है, सो हाउ वी कैन एक्सप्लेन दिस थिंग इज, सपोज वी आर गोइंग फ्रॉम चंडीगढ़ टू दिल्ली एंड इट इज एन क्या 8 लेन हाईवे, ठीक है, हमारा 8 लेन हाईवेज है. सो हाउ मेनी कार्स कैन पास एट अ टाइम? 8 कार्स कैन पास एट अ टाइम. However, if I increase it to 16 lanes, how many cars can pass at a time? 16 cars can pass at a time. So 8 laning को अगर हमने 16 laning कर दिया तो चंडीगढ़ से दिल्ली पहुंचने का आपकी स्पीड बढ़ गई और आपका टाइम रिड्यूस हो गया. Similarly, as the size of your data bus increases from 4 to 8 to 16 to 32 to 64, etc., then the size of your data bus is increasing, the processing speed is of course increasing, and processing time is reducing. Similarly, when we are saying that 8051 general purpose registers, they are 8-bit in size, that means the amount of data they can hold at one time is 8-bit in size. Now, what is the purpose of general purpose registers? It is for the temporary storage of the data during the execution of a program. These are RAM locations only. आपका program memory में जो आपका program है stored है, so what you do is you fetch your data with the help of your address bus. It's like there are two things. One is the data bus, the other is the address bus. Data bus is used to fetch the data, as the name specifies, and address bus is used to specify the address. For example, if I live somewhere and I ask you to go to my home and bring me something, what is the first question you are going to ask me? What is your address? Similarly, when a microcontroller or CPU has to fetch the data or instructions from its memory, the first thing it needs to know is what is the address, and that it does with the help of your address bus. Now, how does the size of address bus affect, or what does it affect?
It affects the capacity of memory.
Right. Our centers, can anyone answer this question? For example, the size of your data bus affects your speed. For example, your size of data bus affects your speed. What does the size of address bus affect?
Size of program memory.
Size of program memory. How can you tell the formula for that?
Ma'am, it is 2 to the power size of address bus.
Address bus, right. So suppose I am saying that 8051 is got 8 bit of data bus and it has got 16 bit of address bus, then the total memory it can map is 2 raised to power n, where n is the size of its address bus, that is 2 raised to power 16. So 64K की memory आप total इसके साथ जो है the size of its memory is dependent upon the address bus. And now coming back to our 8051 general purpose registers, the purpose of these registers are for the temporary storage of the data during the execution of a program. So as you can see from this diagram, the general purpose registers are accumulator, register B, and registers R0 to R7. All these registers are basically 8-bit registers. Apart from this, we have two 16-bit registers also, like data pointer. Data pointer is a 16-bit register, although it can work like two 8-bit registers also, DPH and DPL. Data pointer आपका जब ROM memory access करते हैं या फिर आपको external memory interfacing करना होता है तब आपका data pointer जो है वो use होता है. Then there is program counter. It is again a 16-bit register. Now those who have already studied microprocessor must be aware of what a program counter is. Can anyone tell me what does a program counter do, or what is the significance of a program counter?
Hello, from MIT, ma'am. So
Yes.
program counter keeps the address of next location that is going to be executed.
Right. How does the controller know? Controller को कैसे पता चलता है कि मेरे को next instruction कहाँ से fetch करनी है? हमने ये तो बोल दिया कि वो address बस fetch करता है, but how does it come to know? It comes to know with the help of a program counter. So program counter, why is it 16-bit in size? Because it contains the address of the next instruction which is to be fetched, and the address bus is naturally it is 16-bit in size. So that is why program counter has to be 16-bit. These are all assembly languages. Now the rest of the architecture part will be covered in your second session, but I'll give you a glimpse about C program also. At least this much of knowledge was required for programming it. Another thing is that you must also be aware of the ports. As I told you, there are 4 input output ports: port 0, port 1, port 2 and port 3. And another very interesting feature of a microcontroller is that there is bit addressability in this. Now, what do you mean by bit addressability? That in case of a microcontroller, if you have to use a particular register, then the whole 8 bits of register can be accessed. But in case of a microcontroller, there is bit addressability in the sense that you can address or you can access a single bit itself. Pardon?
Set bit command.
Set bit command. हाँ, वो actually assembly में होता है ना? अच्छा, एक चीज मैं पूछना चाहती थी सेंटर से, because actually जो हमारा 8051 programming in C है, that is going to start from tomorrow. Do you want to, because we still have time, so should we directly go to 8051 programming in C, or do you want me to tell you something about assembly programming as well? Because mostly curriculum में जो है वो assembly programming होती है, लेकिन industry में C programming होती है. So do you want me to directly go to the C programming, or do you want to have a glimpse about the assembly also?
No, ma'am,
So that
please continue on the C.
Pardon?
Please continue on the C
So
language.
okay. Assembly का नहीं कुछ भी करना, C पे ही हम directly आ जाएं. ठीक. So when I was talking about single bit addressability of ports, for example, you have port 0, port 1, port 2 and port 3. तो कभी-कभी क्या होता है, आपको एक single bit को भी change करना पड़ता है. How do we access it? Actually, I'm not having board right now, so what I'll do is I'll write the same in Word. For example, if I'm talking about port 0, as I told you, there are 4 ports which are used for real world interfacing, because these give us the input output pins, and the pin diagram and all will be covered today in the today afternoon session. But right now we are discussing is basically the single bit addressability of controller. So suppose we have port 0, then how do we do the single port accessibility? Port 0 can be accessed as 0.1, the various pins. So the 8 pins of port 0 can be accessed as P0.1, 0.2, etc. up to P0.7. Now what does this mean? This specifies the port and this specifies the pin number. Now it starts from actually P0.0. That means the first pin of port 0 is P0.0 and there are total 8 pins, so the last one will be P0.7. Similarly, if I want to write the fifth pin of port 3, how will I write it? Fifth pin of port 3? Yes?
P3.4.
No. Yeah, you said P3.4, that's right. So because we have to access the fifth pin, so 4 is actually because we are starting from 0. So this is known as the single bit addressability of the various ports, and these will be used like this. Now in case of assembly programming, you write like P0.0, P0.1, etc. However, in C programming, we write the same thing by using asterisk. We don't say P0.0, but we say P0 asterisk 0. So please keep this thing in mind, because these small things, they produce error in your program. So you have to keep in mind how to write your code in the right way. So this is one difference. Another thing is, suppose I have to specify my data. Now there are various ways of specifying your data. Mostly hex data is used. That is why I say hex file is created in your when you convert your program into your hex file machine language. So whenever you have to specify hex data, then suppose I have to specify 10H. Now here H represents my hexadecimal data, and if I am writing only 10, I am not specifying anything. That means it is a decimal data. Similarly, you can have binary data also, so you write 1000, etc., and then you write B with it. But in case of C language, if I want to write H, it will be 0x10. So in this case, my 0x represents the H, basically hexadecimal. Similarly, if I have to represent 55H in C, I will write 0x55. Is this clear? Does anyone have any doubt in this? Because you are going to represent your data, etc. Yes?
Ma'am, from MIT,
Yes,
this
sir.
X should be capital or small?
Actually, compiler is case insensitive. Mostly we take it small x.
Okay.
Mostly it should be small x.
Okay.
But otherwise, whenever you're writing your program in Keel, then it is case insensitive. So for example, you're writing your instruction, you can use capital as well as small, etc. But when we're specifying it for hexadecimal, you have to take small one only. Any other doubts?
Hello.
Till here, you have any doubts? Any other center has any doubts?
Hello, yes ma'am, from Mulana Engineering College.
Yes, yes.
Now, how we will differentiate the address between this ROM and RAM? How we will represent it?
Address in ROM and RAM means?
Yeah, if we want to find the data against the address in ROM, how we will tell the key that we extract the data from the RAM or ROM?
Okay.
How we will differentiate
actually, for that we have one instruction, because otherwise, whenever you are saying anything, you are talking about RAM only. ऑल दीज थिंग्स ना, ये एक्चुअली आपका रैम एलोकेशन रोम पार्ट जो है वो आफ्टरनून में कवर होना था, बट स्टिल आई टेल यू कि आप जब भी बात कर रहे हैं, दैट से आप 55H लिख रहे हैं, आप मेमोरी की बात कर रहे हैं, यू आर टॉकिंग ऑफ रैम ओनली। बट इन केस यू वांट टू स्पेसिफाई ऑफ रोम, तब हमारी जो इंस्ट्रक्शन होती है वो होती है हमारा असेंबलर डायरेक्टिव के अंदर सी, मूव सी। सो वो जो C है that represents the code memory. Code memory means your ROM memory. Let me see if I'm having assembler directive slide with me. I'll show you. How do we do that? So your question basically for other centers, I would like to tell. The question is regarding how do we differentiate fetching the data from data memory, that is RAM and ROM. So I'll show you the addressing mode in which ROM is accessed. Yes. So this is a kind of, there are various addressing modes, and index addressing mode is basically used for program memory, that is your ROM memory. So otherwise, if you write move a comma something, that means it is a your your RAM memory. But when you write move C, then this C represents it's a code memory. So that means you have to fetch the data from code memory.
Okay.
Am I clear?
Thank you. Thank you.
Okay. Any other doubts?
Thank you.
Does any other center have any doubts, or should I directly go to C now? How to write your program in C? आप लोगों को कोई डाउट है अभी तक? Now coming to 8051 programming in C. So this we have already discussed why we need to program 8051 in C. There are some people who are more comfortable with assembly. They still use assembly, but in industry mostly embedded C is only used for programming the controllers for various reasons. I've already told you it is easier and less time consuming to write your program in C rather than assembly. C is easier to modify and update. There are some inbuilt functions which you can directly use. The best part of C is portability. It is not machine specific. You need not, if you want to migrate to some other controller, you need not learn the mnemonics of that, because mnemonics are hardware specific only. Now, before moving to this, I want to ask you one question, that as I said, people are still using assembly. कुछ तो advantage होगा?
After converting any code in X5, the assembly
Hello, ma'am.
हाँ जी.
This is from MIT. Actually, in assembly, we have code density. Like code length will be very less as compared to the length of hex file in C.
Right, very right. That's true. See, what we are saying till now is that you write your program in C and that will be shorter in size. And when you write your program in hex, of course, it will be lengthier than the C. But what is ultimately burned into the controller? That is your hex file, or that is your machine language. And the size of the program, or the size of your hex file, if you write your program in C, is larger as compared to the size of the hex file if you write your program in the assembly. So in those particular cases where, because memory size is very critical, suppose you have 4K of fixed ROM या memory, तो वहां पे आपको बहुत ध्यान से अपना प्रोग्राम लिखना है ताकि जो आपका अल्टीमेटली हेक्स फाइल बने उसका साइज स्मॉल हो. So there is this one advantage of assembly over C. I haven't heard of that. Debugging का it is easy. स्टेप बाय स्टेप वो कर सकते हो आप. एक्चुअली क्या होता है कि सी लैंग्वेज में भी जब आप उसकी कंपाइलिंग करते हो ना, तो फर्स्टली वो पहले असेंबली ही कन्वर्ट करता है, उसके बाद ही वो सी में जाता है. सो मे बी बिकॉज ऑफ दैट डिबगिंग भी इजी है. दैट मस्ट बी द रीजन. नाउ कमिंग टू आवर C language. it is very important to understand the various data types for 8051. Now, why do we need to understand these data types? Because one of the goals of 8051 programmer is to create a small hex file, because we have limited on-chip memory. So it is worthwhile to re-examine the various data types. This will help the programmers to create smaller hex files. अगर आपको पता होगा कि हमें particular data के लिए कौन सा data types चाहिए, तो आपका accordingly hex file जो है वो small बनेगा. The most widely used data types, those who have already studied C, it will be easier for you to understand the data types. The most widely used data type for 8051 is unsigned char. Char is basically character data type. It is an 8-bit data type because our controller is also 8-bit data type. So obviously हमारा जो most widely used data type है, that is unsigned char. And it is in the range of 0 to 255 basically, because आपका 8-bit है, so 2 raised to power 8, that is 256. So 0 से लेके 255 आपका डाटा जो है वो अगर उसकी वैल्यू ranges from 0 to 255, then the type of data type which you will be using in your application will be unsigned char. And there are two things, one is unsigned and the other is signed. जो एप्लीकेशंस आपकी साइन नंबर्स हैं, साइन नंबर्स मींस जहां पे आपके नेगेटिव नंबर्स भी इन्वॉल्व होते हैं. फॉर एग्जांपल कोई आपकी ऐसी एप्लीकेशन है जिसमें नेगेटिव भी जाता है, नेगेटिव में भी टेम्परेचर अलर्ट से, तो वहां पे आप अनसाइंड नहीं लेंगे, वहां पे आप साइंड कैर लेंगे. सो जहां पे आपके नेगेटिव नंबर्स है तो ऑब्वियसली उसकी रेंज क्या हो जाएगी, अगर टोटल 256 रखना है सो -128 टू +127. So in that case signed char will be used. And in case आप कुछ नहीं लिखते हैं, आपने उसमें सिर्फ char लिख देते हैं, so that is default signed. But in case you have to specify an unsigned number, you have to write unsigned char with it. Otherwise it will show error in your program. Is it clear? Any doubts in this? Because this is the most widely used data type which is used for programming of 805. What I'll be doing is, by discussing every data type simultaneously, I'll be demonstrating some example also, so you will be better able to understand it. So now, firstly, let me show you what is the structure of an C language program for 8051. So as we know, initially you need to have a header file. So the header file for 8051 is #include reg51.h. जैसे हम C में करते हैं stdio.h या iostream.h, C++ वगैरह में करते हैं. So the header file for 8051 is #include reg51.h. Then we use void. So these are and then as we know in C language, our main program, it will be written in this. ये नेटवर्क 4 एक्सेस कैसे जाएगा, मुझे इसको जूम इन करना था. कोई बात नहीं, हो गया. Is the screen visible to you? Is the size comfortable for you to read?
Yes, ma'am.
Okay. So firstly our header file will come, then void main void, then curly brackets, and you will write your main program within these curly brackets. This is the structure for your C program. And as we know, the subroutines, they are written outside the main program. So firstly you have to declare your subroutine initially before you start with the void main void, and after your main program you will write the subroutine. Tomorrow we'll be doing some examples wherein delay program के लिए हम subroutine किस तरह से लिखते हैं, तब आपको exactly समझ में आएगा कि हम ये कैसे करेंगे. So we were initially discussing about our signed char. Now suppose we have one example. Suppose this is our program. Write an 8051C program to send values 00 to FF to port P1. Now, see, the first thing which we have to see is कि हमारी जो values हैं जिनको हमने P1 में भेजना है वो क्या है 00 से FF. तो 00 से FF की range कहाँ तक है? That means 0 to 255. So 0 to 255 means which type of data type should be assigned to it? Of course, it should be unsigned char. So that's why. So firstly, I will write hash include reg51.h, then void main void. I'll write this problem there and then एक एक करके हम एक step को समझते हैं. So this is the problem. Write an 8051C program to send the values 00 to FF to port P1. Suppose port P1 के ऊपर आपका कुछ display device लगा हुआ है. Let's say 8 LEDs आपकी लगी हुई हैं और आप चाहते हैं कि ये value जो है ये आपकी LEDs के ऊपर glow करे. Simple example अगर हम लें तो उसका C में program हम कैसे लिखेंगे? So first thing we need to understand is कि जो data type हमने लेना है that should be unsigned char. For that we'll take any variable. Any variable, you can give it any name. Let's say I'm giving it a name X. So unsigned char X. Now the value of X should range from 0 to 255. So what I will do is I will use a for loop, and this for loop will begin from 0 and it will go up to 255. So this is the syntax for our for loop. So as you can see here, X value starts from 0, you increment it 1 and then it goes on doing this till it reaches the value 255. So for this for loop, that's it. That's it. So what's happening is that in case of C language, in case you want to assign any value to a particular, let's say port P1, then what you have to do is P1 is equal to X. So automatically what will happen, whatever value of X will be here, it will be assigned to P1. So what will happen initially, X is 0, 0 will be assigned to P1. Then X will be incremented by 1, 1 will be assigned to P1 and so on. This will keep on happening till the value reaches 255. That's it. Any doubts in this? Does anyone have any doubt about this program? Deepika, एक mouse मिल सकता है? तो mouse से थोड़ा रहता comfortable रहता.
Program is we want to see this
No ma'am, no doubts.
perception. We can't identify because its speed is in microseconds. We need to do
Yes. Okay, so there is one doubt here by one of our participants present here. So what very good question he has asked is that you have written your program here and suppose you burn this in the controller on your hardware part, you have LEDs there, but will you be able to see this particular thing 0 to 255? आप वो LEDs पे देख पाएंगे? नहीं, because it will happen so fast. 0, 1, 2, 3 ऐसे करते करते वो 255 पे इतनी जल्दी पहुंच जाएगा कि आप देख ही नहीं पाएंगे. उसके लिए हम क्या करते हैं, हम इसमें डिले का प्रोग्राम देते हैं. डिले का प्रोग्राम हम ग्रेजुअली आई विल टेल यू हाउ टू इंट्रोड्यूस डिले, वो हम करेंगे इसमें. बट टिल नाउ इज इट क्लियर द सिंपल प्रोग्राम? नाउ मैं क्वेश्चन एक पूछना चाहती हूँ आपसे. आप प्रोग्राम देखिए, इसमें हमारा ये जो फॉर लूप है, अगर मैं इसमें यहाँ पे एक सेमीकोलन दे दूं तो क्या होगा?
Will get 255 only.
Will get 255. Yes. Why?
Because the semicolon.
देखिए मैं इसलिए आपको मैं बता रही हूँ क्योंकि these are some of the small mistakes which we do और उसकी वजह से हमारा पूरा लॉजिक ही चेंज हो जाता है. सेमीकोलन matters so much. हाँ बताइए सर, आप कुछ आंसर कर रहे थे.
Ma'am, this semicolon actually for loop. What should I say, ma'am? For loop actually execute only one instruction after its this x plus plus, and semicolon will be just one instruction like that.
It is a statement terminator basically. Yes. So basically what will happen is that अगर आप इसके साथ में एक सेमीकोलन दे देंगे तो क्या हो जाएगा कि वो पहले 0 1 2 3 ऐसे इंक्रीमेंट करता रहेगा, बट बिकॉज सेमीकोलन इज यूज्ड एज अ स्टेटमेंट टर्मिनेटर इट विल नॉट गो टू द नेक्स्ट वन. सो जब वो 255 पे पहुंच जाएगी x की वैल्यू, it will terminate there, and that 255 की वैल्यू will be then given to p1. So that's why it is very important to know where to use this semicolon and where not to use this semicolon. Now, as sir, you were asking me question, delay. For in this way, we can give a delay. Delay कैसा है कि ये क्या कर रहा है, 0 से लेके 255 तक जाएगा, तो उसमें कुछ टाइम लगेगा ना उसको एग्जीक्यूट करने में. So that ways आपका बीच में जो है वो डिले आ सकता था, लेकिन वो डिले कैसा होता है कि एक पर्टिकुलर ऑपरेशन के बाद का ऑपरेशन होता है. Another thing is हमारा यहाँ पे you had to send the value of x only to port P1, but suppose you wanted कि ये values P1 में भी जाएं और P2 में भी जाएं, तो अगर मैं ऐसे लिख देती हूँ यहाँ पे, what will happen?
Hello.
Yes.
Yeah, ma'am. Just now you said the value of P1 will be 255, but I think at 255 the condition will be true. So in that case, again the value of P1 should be 256, not 255 then.
Hello. No, it will be 255. So total values जो है वो 0 से लेके total value जो है वो आपकी 256.
But then the P1 equals to x can't be executed, right?
आपकी 0 value भी तो गई है ना वहाँ पे.
Hello. 0 till 255. Till 255 the condition is true. So as long as the condition is true, it will execute the null statement. But
Yeah.
the condition is false at x increments to 256.
अभी आपके सेंटर पे आते एक मिनट, एक डाउट है, पहले वो क्लियर कर लेते हैं. हाँ जी,
Hello,
हाँ जी,
ma'am.
बोलिए.
Ma'am, this is an infinite loop.
Infinite loop? No.
Yes,
this is
ma'am.
not infinite loop.
Ma'am, the value is 255. When the value is 256, then a cycle is formed.
Again starts from 0 actually.
And again, the value of x is 0. That is an infinite loop.
This is not an infinite loop. How
It
can
should
you
be
say
less
that?
than
आपकी
255,
वैल्यू
not equal to.
चली गई, उसके बाद वो 0 पे करने के लिए क्या किया आपने कि आपकी वैल्यू फिर से 0 हो जाएगी?
Ma'am, excuse me, let me explain you. This being an 8-bit data, and when we are there in the for loop, at the end of the iteration, that is x is equal to 255, after that it will increment to 256, and 256 will become 0, because
Right.
there is an overflow, and the register will, on the addition of 1, it will have only zeros over there internally, and so again you enter into the loop, that is x is equal to 0. And so what sir has said is that it will enter into infinite loop. Now it depends on the compiler how it handles the overflow, and then how it is being converted to the hex files or the assembly. But logically it says that it will go to x is equal to 0, and so the loop will start again after 255, 256. 256 means it is basically 0. If the register is 8-bit register, the moment it adds 1, it is all 1 basically over there. 255 means all 1. The moment you add 1, it will become all zeros. The moment it become all 0, it will be x is equal to 0. And so you will be there in the for loop itself. Now it becomes a practical question, what happens in the microcontroller after conversion.
सर एक्चुअली क्या है कि x is equal to 0 के बाद ये x plus plus एग्जीक्यूट होगा. इट्स नॉट दैट x less than 255 के बाद भी एक x plus plus आएगा. You are saying 255 के बाद वो एक उसमें
the moment we reach x is equal to 255, after that incrementation is taking place. So this is x plus plus. So this incrementation is taking place at the end of the loop.
That's what I'm saying, sir. X is 0, then x plus plus, that means it is incremented by 1. Then it checks the condition if x is less than equal to 255. No. Then again x plus plus. So it will keep on repeating till that value is 255. Now, when your value will reach 255, that condition has reached. then it will not be x plus plus. That's what I am saying. I have a doubt if it will be infinite loop, but what
Ma'am,
we
it
can do
should be
is,
less than 255, not equal to.
All the participant and let them see it practically.
yeah, that's what I'm saying
This
कि
is a good
आपके
example,
पास
by the way.
अगर किट वगैरह कुछ है तो आप इसको एलईडी पे जलाकर देखिए, बट आई एम नॉट श्योर इफ इट विल बी एन इनफाइनाइट लूप.
It will be actually.
अच्छा, कोई और सेंटर से भी बोल रहे थे ना कुछ, some other center?
Ma'am, it should be x less than 255, not equals to. Because see, the range of character is 0 to 255. Once it reaches 255, again if I'm including it, again moves to 0 only. So it's an infinite loop.
ठीक है, ये टेस्ट करके देख लेंगे सर.
Actually, ma'am, it's on Turbo C. Actually, I've tested on the C program. Like,
okay,
it's already tested actually.
okay, okay. So हम इसको x is equal less than 255 कर देते हैं. So my question was that suppose you say for x is less than 255 x plus plus. Now how will this value send both these values to port 0, port 1 and port 2 as well? That was what my question was.
मैम अब ये वैल्यू 255 से लेस रहेगी अप टू 254.
ना, मेरा क्वेश्चन ये है कि in earlier case what was happening was that these values were being sent to P1. Now I want is that these values should go to P1 as well as P2. Then whatever I have written, is it fine, or
No,
I need to
ma'am.
do something else?
Ma'am, we have to include braces actually after for loop.
Yes. What is happening is that in this case, immediate after इसके जो instruction है आपकी P1 is equal to X, that will be working fine. But in case you want to include P2 as well in the program, you need to use braces. So what is happening is both these instructions are now included in this for loop. Clear? Now, in this case, the maximum value was 255. So as we have discussed also, one of the centers, they said that it should be less than 255 because it's an 8-bit microcontroller. तो आपका जो unsigned char की भी limitation है वो कितनी है, 255 तक ही है. Suppose I want values more than 255, then unsigned char will not work. In such cases, the data type used will be unsigned int. So unsigned int is basically a 16-bit data types for those values which should fall in the range 0 to 65535, or in case of hex, we can say which fall in the range 0 to FFFFH. In such cases, we make use of unsigned int. And whereas your char took 1 byte of memory, unsigned int takes 2 bytes of memory. Of course, because it is a 16-bit data type. Now, सपोज हमारा जो पहले वाला एग्जाम्पल था, इसमें अगर हम इंस्टेड ऑफ यूजिंग दिस अनसाइंड char x, सपोज आई हैड यूज अनसाइंड int x, कुछ एरर होना था? विल इट इंट्रोड्यूस एन एरर? Yes, sir, centers. My question is, in the same example wherein I had to send these values, instead of char, if I had used this int, would the compiler produce some error?
Ma'am, this will produce the error in the statement P1 is equal to X. Because P1 is 8-bit and X is 16-bit.
But the values you're sending only up to 255. वैल्यूज तो आपकी 255 तक है. सो माय क्वेश्चन इज कि कैर की जगह पे अगर हम इंट लगा देंगे तो क्या एरर देगा वो कंपाइलर?
No, ma'am, there is no error, I think.
Why?
Maybe you are setting the range of X is up to 255. But in what I'm thinking that if P1 is 8-bit and X is 16-bit, the value should be same. The number of bits should be same. Whether you are
That is
taking as
true.
up to
That is true.
255 or 6536,
No,
number
that
of
is
bits
true
should be
because that
same.
is one condition of programming, that the source and destination should be of the same size. That is
Yes,
true. You
yes.
are saying whatever is it is right, but that would have created an error if I had put a value of like this here. Then it would have produced an error because X is more than 8-bit whereas P1 is an 8-bit register. But in this case, my value of X is going only up to 255. Now, should it produce an error or not? So one answer I have got is no, it should not produce any error. Now what about other centers? आपका क्या कहना है? आप कह रहे हैं करना चाहिए? नहीं.
Because of community C को या somebody को check करते हैं. Like in calculator, if we get 0000H, that decimal value is 0 only. But in hex we are giving 0000H. Is it error free or is it error? In calculator, we get 0000H.
पर हम तो यहाँ दे ही नहीं रहे ना, 0000H तो दे ही नहीं रहे हम.
इसको 255 वैल्यू दो, अगर हम अनसाइंड 8 लिखें तो वो उसके लिए मुझे लग रहा है कि 16 लोकेशन शायद उसके लिए वो रखे. तो वो जो रेस्ट ऑफ द वो बच रही है लोकेशन में 0000 शायद
नहीं नहीं नहीं
ऐसा नहीं है.
हाँ जी, बाकी सेंटर्स क्या कह रहे हैं इसके बारे में?
Good afternoon, ma'am.
जी, गुड आफ्टरनून.
Myself Gaurav Sewal from Dronacharya College of Engineering. It won't give any error, but the only difference it will make, the memory which will be allocated for X will be more in this case, while in the CAR the memory allocation will be less.
Exactly, this is the thing. आप लोग भी सुन लीजिए. The right answer has come. Actually what is happening is that देखिए हमने जो range इसकी की थी, what was the range? It was from 0 to 65535. When you say unsigned int X, that means you are defining that it can have a value from 0 to 65535. 255 also comes in that range only ना. 255 तो आपकी रेंज उसमें आ ही रही है, तो आप उसको अगर इंट भी दे देते हैं तो वो कोई एरर नहीं देगा वो, बिकॉज 255 की वैल्यू भी इंट के अंदर आती है, बट इट विल unnecessarily eat 2 bytes of your memory wherein only a single byte of memory would have been sufficient. This is very important in case of a microcontroller because you have limited on-chip memory. So you have to use int only in those cases wherein your value should exceed 255. Am I clear?
Can you give the reason why it takes 2 bytes of memory?
Because it's a 16-bit data type.
Yeah, so the rest of the 8 bits.
नहीं 16-bit डेटा टाइप है वो, वैल्यूज तो उसकी 0 से लेकर 6535 तक जा सकती है, बट उसका जो डेटा टाइप है वो बिकॉज दो मेमोरीज लेता है वो, उसकी वैल्यू से कोई लेना देना नहीं. लेट से आप 255 वैल्यू लेते हैं तब भी वो डेटा टाइप तो 2 बाइट्स ऑफ मेमोरी लेगा ना. हाँ ठीक है, तो आपका कुछ एरर नहीं है. ये वाला जो मैंने प्रोग्राम लिखा इसमें वो कंपाइलर को कोई लेना देना नहीं है इस चीज से कि आपने इंट ले दिया या कैर ले दिया, बिकॉज फॉर इट इंट वैल्यू इज ऑफ कोर्स 255 लाइज इन इट. यस, अगर हम यहाँ पे वैल्यू, यहाँ पे अगर सपोज हम कैर लेते और यहाँ पे वैल्यू आपकी लेट से 1, अभी आप फिलहाल नीचे P1 इज इक्वल टू X को भूल जाइए, हम उसको असाइन P1 में नहीं कर रहे हैं, बट आई एम टॉकिंग ओनली अबाउट द वैल्यू X. If it is exceeding 255 but the data type which you are assigning is a char not int, then it will produce an error because char की limitation है कि वो सिर्फ 255 तक ही जा सकता है, लेकिन आपने उसको वैल्यू कितनी दे दी, ज्यादा दे दी, तो वो एरर आपको देगा. ठीक है, so this was all about int. Now let us see some example wherein we require int. For example, suppose I am assigning the value 55H to port P1. Now what is 55? It is nothing but 01010101. So this value you have assigned to P1. Now you want to toggle this value. Toggle in the sense, what is toggle? Toggle means whatever value was 0 should become 1, whatever value is 1 should become 0. So what should be the toggle value for 55? Can anyone tell? 55 is nothing but 01010101. So what should be the toggle value? It should be AA. Now suppose this is a condition wherein 8 LEDs are connected to port P1 and you have to toggle those LEDs. So what you did is P1. So what you have to do is basically you have to just write a logic in the sense कि 0 should become 1 and 1 should become 0. Simplify करने के लिए I can also use 0x00 and 0xff also. ताकि वो क्या हो जाएगा, जो पहले सारी 0 थी वो 1 हो जाए. That's it. और आप चाहते हैं कि आपकी LEDs इस तरह से टॉगल करे, बट like as आपने पहले भी क्वेश्चन पूछा था, अगर हम सिंपल इतना कर देंगे we will not be able to see because the change will happen so fast, आपको पता नहीं चलेगा. तो हम क्या कर देंगे, हम बीच में एक डिले लगा देंगे. Now one way of writing a delay is by giving a for loop. हम क्या करते हैं कि जब उसको हमने 55 वैल्यू दिया, उसके बाद हम एक for loop लगा देते हैं और उस for loop की वैल्यू जो है now it's very important in this case to attach a semicolon because अगर आप ये semicolon नहीं देते इसका लॉजिक चेंज हो जाएगा. उसका मतलब क्या हो जाएगा कि वो वैल्यूज आप इंक्रीमेंट, और वो ऑफ कोर्स रॉन्ग है बिकॉज P1 इज एन 8-bit वैल्यू. तो वो हमारा एम नहीं है. अवर एम इज ओनली टू क्रिएट अ डिले. हाउ इट इज क्रिएटिंग अ डिले कि आपकी वैल्यू पहले 0 थी, 0 से वो इंक्रीमेंट होते होते 50,000 तक चली जाएगी एंड दैट वे सम डिले इज बीइंग क्रिएटेड. And then again after this so this is your program. Now in this case because X value has to reach up to 50,000, this is out of jurisdiction of char, so that is why I have used the data type int in this. Clear? So this is one application wherein you will prefer to use an int and not a char. Any doubts? Anyone has any doubts? ये कौन सा center है ये?
Hello, from MIT, ma'am.
Yes, sir.
So I think there may be one more option, that is we can use sleep instead of this for loop.
You can use
sleep, and the values are given in that millisecond within bracket sleep command.
हाँ वो भी करेंगे. मैं एक एग्जांपल आपको बता रही हूँ जिसमें हम फॉर लूप ऐसे, तो जहाँ पे आपको स्पेसिफिकली टाइम डिले स्पेसिफाई करना है, एक ऐसी एप्लीकेशंस में जहाँ पे बहुत क्रिटिकल है, लेट्स से 10 मिलीसेकंड्स, इतना ही होना चाहिए, उससे ज्यादा नहीं होना चाहिए, वहां पे आप टाइमर्स भी यूज करें. You can use your timers also. Then there is one another way also of using the delay, which I will tell you tomorrow in the tomorrow class. But this is one very crude way of giving a delay. Wherein जैसे LEDs हैं, LEDs के बीच में some delay should be there. वो some delay can be anything. We are not bothered कि वो exact उसकी value क्या होनी चाहिए. वहां पे हम एक for loop को लगा लेते हैं. उससे क्या हो रहा है कि it's only like your values are getting incremented, so it is taking some time to reach to that particular value, so some delay is being generated. तो जहाँ पे specified नहीं है कि मुझे इतना ही delay, this much only amount of delay is required by me, there I use this for loop. Now apart from this there are other ways also, wherein suppose I wanted that a delay of 10 milliseconds should be there in the toggle. So either way is by using a subroutine. Subroutine में हम delay को specify करते हैं, or else what you can do is you can use a timer also. So that is another separate topic, how to give a delay of a particular time only. I will try to include one session on timers also, because timers को कैसे program करना है using embedded C. That session I will cover on maybe It can be taken tomorrow or else it can be taken on Thursday or Friday. Any other doubts? आप लोगों को कुछ doubt है इस चीज? Any other doubts for other centers? No? Now, another very important data type in 8051. This is specific to microcontroller because all the other rest data types are the same, which आपकी C में भी आप पढ़ते हो, like char, float, int, etc. They are there for 8051. But this is specifically for microcontroller. It is an S-bit data type. Now, why it is S-bit data type? Because as I told you that there is an option for single bit addressing in case of microcontroller. So single bit addressing के लिए आपका जो data type है that is S-bit data type. And इसका जो syntax है that is S-bit, then whatever name you want to give equal to that particular port pin. Syntax is S-bit, whatever name you want to give. In this case, for example, LED name has been given, then this is equal to P1*0. So that means in your program, wherever you want to use the pin number V1.0, you will not write P1*0 in your main program, you will write LED. So automatically it will take that LED means P1*0. Another thing which you must keep in mind is that while declaring the S-bit, it is always declared globally. What is meant by globally declaration? Global declaration. For example, this is my program. I will declare it here. S-bit LED is equal to P1*0. Now, suppose in my main program, so I want to toggle the bit P1.0. So I will not write P1.0 is equal to something. I've already declared it as given it a name LED, and so I'm writing LED is equal to 0 and then LED is equal to 1 because it's a single bit. So this is how we make use of the bit S-bit. Always remember, S-bit is to be declared globally, that is outside your main program initially. So this is one example wherein we have to write an 8051C program to toggle bit D0 of port P1, that means P1.0 50,000 times. So what I have done is I have declared S-bit out of main program by write, and I have given my bit name my bit. You can give it any name. You can give your name also if you want. So S-bit, my bit is equal to P1*0, and then how many times do you want to toggle it? 50,000 times. So for Z is equal to 0, as Z is less than 50,000, Z plus plus, then my bit is equal to 0 and my bit is equal to 1. So this particular toggling process, it will how many times it will occur? 50,000 times. 50,000 times. 0 1 0 1 0 1 0 1 ये प्रोसेस अगर आप डिले की बात कर रहे हैं तो वो हम फॉर लूप बीच में लगाएंगे, बट यहाँ पे हमारा मेन एम क्या है कि ये पर्टिकुलर टॉगलिंग का प्रोसेस 50,000 टाइम्स रिपीट होना चाहिए. सो दिस इज नोन एज लूप. जैसे असेंबली में दोज हु हैव डन असेंबली, वहां पे लूप होता है, लूपिंग डीजेएनजेड इंस्ट्रक्शन को हम यूज करते हैं लूप का लगाने के लिए. इस केस में हम इस तरह से लूप देते हैं. So these were the various programs for the data types, and tomorrow we'll take up some programs that how to give the delay using either C for loop or by using a delay subroutine. And in today's class, what all we have covered is we have seen an introduction to the microprocessors and microcontrollers, what are the various differences between microprocessors and microcontrollers, and what are the applications of them, then how do we choose a particular microcontroller, what are the various data, what are the various memory types which are used for controllers, how are they differentiated, what is the block diagram of 8051, which was the core introduced by Intel in 1980s, and then we saw what are the various programming languages which are used to program these controllers, what are the main differences between them, what are the various advantages and disadvantages of particular assembly language or C language, and then we saw how to write a program in C language, what are the various data types which are used for programming, and with each data type we have seen examples of these data types. And tomorrow's class we'll do some more examples, and in the morning session we'll do some examples, and afternoon I'll give you some practice tasks to write some programs, and then we'll discuss the same on Thursday, whatever examples I've given you. So that is all for today's class. Now let us ask from you in case you have any doubts. NIT Greater Noida. Yes, Meenakshi? Any doubts?
Thank you, ma'am.
Okay.
From MIT, ma'am.
एक second. हाँ जी?
Yeah, from MIT. So one doubt is there. Actually, you are writing this caret sign, but you are pronouncing it as your this asterisk. So it is not very clear. You are typing caret sign, but you are saying asterisk. So are you getting? You are typing caret sign caret. Hello.
Yes, yes.
Ma'am, you are typing caret sign P1 caret 0, but you are pronouncing it as your asterisk.
Asterisk.
This sign is now asterisk.
Okay, caret sign, whatever you may call it, but आपको उसमें one, I call it asterisk, it's my way of speaking, तो आप उसमें caret sign ले लीजिए, ठीक है? Yes, आप कुछ पूछ रहे थे? डिले, इसको कैसे निकालना है? मतलब लेट्स से 40,000 अगर आपने लिया तो उससे एक्चुअल कितना डिले जनरेट हो रहा है? एक्चुअली असेंबली में तो आप कर सकते हो, बिकॉज असेंबली में क्या होता है कि आपके पास मशीन साइकिल का कॉन्सेप्ट है, और फिर आप उसके बाद लूप के अंदर देखकर कि अगर एक इंस्ट्रक्शन जो है उसको इतने मशीन साइकिल लग रहा है तो टोटल टाइम आप देख सकते हो. बट व्हेन यू आर सेइंग फॉर z इज इक्वल टू 0, z इज लेस देन 50,000, z प्लस प्लस का आप एज सच कैलकुलेशंस नहीं कर सकते हो. प्रैक्टिकली अगर आपने इसको देखना है तो आप इसके साथ एक ऑसिलोस्कोप लगा सकते हो. ऑसिलोस्कोप में आप एक स्क्वायर वेव जनरेट करके देख लो. लेट्स से आप पहले हाई दे दो, फिर एक पर्टिकुलर वैल्यू दे दो और उसको लो दे दो, देन फ्रॉम दैट ऑसिलोस्कोप यू कैन सी कि वो कितना टाइम डिले जनरेट हुआ, उससे फ्रीक्वेंसी निकाल सकते हो. बट एज सच 50,000 वैल्यू करके कोई फॉर्मूला नहीं है. असेंबली के अंदर हाँ है, असेंबली में यू कैन कैलकुलेट मशीन साइकिल्स और लूपिंग होती है उसमें, नेस्टेड लूपिंग एंड लूपिंग, वहां पे आप कर सकते हो. अनदर थिंग इज, अगर आप जैसे बोल रहे हो कि हमें कैसे पता चलेगा कि कितना देना है, तो वो उसके लिए अलग प्रोग्राम्स हैं कि लेट से मुझे 10 मिली सेकेंड्स का ही डिले देना है, तो वो कैलकुलेशन हो जाएगी, वो मैं कल करवाऊंगी.
गुड आफ्टरनून.
द्रोणाचार्य ग्रुप ऑफ इंस्टीट्यूशंस, ग्रेटर नोएडा.
I just have one question.
Yes, sir.
If we use nested for loop, can we multiply this delay?
Of course, yes, we'll do. Tomorrow I'll tell you the concept of nested looping. How to make a larger delay with the help of nested looping. Loops within a loop.
Multiply the delay by using that.
Yes, of course, we can do that.
Okay.
Anything else, sir? MIT?
No, ma'am, not now.
Okay, sir. MIT Merit?
Yeah, ma'am, we already discussed.
Okay. Dronacharya College of Engineering, Gurgaon. Any doubts?
Hello.
Yes, ma'am.
Ma'am, you have given that for loop for 50,000, how to calculate the timing of that delay?
same question actually one of our participant has asked here also. See, as I already told you that in C language, when you have to give a very crude type of delay, let's say there should be some delay between your LEDs, some delay. We are not specifically concerned about how much delay. Then you give for loop. बट इसमें सी में इसको यहाँ पे कैलकुलेट करने का कोई तरीका नहीं है. आपको अगर स्पेसिफिकली पर्टिकुलर टाइम डिले का ही करना है तो आप टाइमर्स को यूज कीजिए. मैं कल की क्लास में आपको वो करवाऊंगी.
Thank you.
In case of assembly language programming, there is an option, because what you do is उस केस में यही चीज के looping में होती है. So you
Yes.
know one machine cycle, for example, it is 1.085 microsecond for microcontroller. So one machine cycle इस instruction को लगते हैं. Total कितनी instructions थी हमारे total machine cycles कितने लगे, multiplied by one machine cycle is the total amount of delay you calculate it very easily in that case. But in this case if you say कि हमें 50,000 से पता चल जाए कि कैसे calculate करना है, उसका formula ऐसा कुछ नहीं है. What you can do is that you can generate one square loop, और वो square loop में आप क्या कीजिए, उसको पहले high दे दीजिए, फिर आप अपना delay दीजिए, low दीजिए, उस oscilloscope में you can then calculate that what is the delay which is being calculated.
Okay, okay. Thank you, ma'am.
Okay. MMU Mulana.
Yes, ma'am. Do we use any other header files besides registered 51.h?
Yes, there are other header files also. That depends upon your application. Maths करके होती है एक maths.h करके. There are.
Thank you.
जहाँ पे आपको कॉम्प्लेक्स मैथमेटिकल यूज करना है वहां पे आप हेडर फाइल्स यूज करते हैं. और बट इस हेडर फाइल में reg51.h इट कंटेन्स लाइक आप p1 लिख रहे हैं, सो इट नोज ऑटोमेटिकली कि वो p1 मींस उसका एड्रेस क्या है. दीज आर स्पेशल फंक्शन रजिस्टर्स. वो आपको वो स्पेसिफाई करने की जरूरत नहीं है कि वो पर्टिकुलर उसका कितना एड्रेस है. सो आपका वो सारे एड्रेसेस वगैरह हेडर फाइल के अंदर आ जाते हैं reg51.h. बट इट डिपेंड्स अपॉन योर कंट्रोलर. फॉर एग्जांपल अगर हम 8051 यूज करें देन इट विल बी reg51.h. सपोज अगर हम आर्म का माइक्रो कंट्रोलर यूज कर रहे हैं LPC2148, सो उसका LPC2148.h. मतलब हर कंट्रोलर के हेडर फाइल अलग रहेगी. ये नहीं कि सबके लिए एक ही हेडर फाइल है.
Thank you.
दैट यू हैव टू सी कौन सा कंट्रोलर आपने लिया. ठीक है. Okay, so that's all for today. And in the afternoons, today in the sense for my session, in the afternoon session, we'll start at 2:30 by Dr. Baban Kumar. He'll be telling you about architecture of 8051. So we'll come at 2:30. Thank you. A very good afternoon to all of you. Welcome to this second session on our FPP on embedded C programming of microcontrollers. In the morning session, we've already seen a glimpse of the introduction to microcontrollers and the various programming languages as well as the C language. And in this session, we have with us Dr. Bhavan Kumar. He is senior scientist from Central Scientific Instruments Organization, Sector 30. Dr. Bhavan Kumar is basically an electronics engineer who has a vast experience of about 15 years. He's mainly worked on embedded system and carried out various projects based on microcontrollers as project leader. He has done his doctorate from Thapar University and postdoctorate from United States of America. And today he will be giving you an idea about the architecture of 805 microcontroller. Over to you.
Thank you, ma'am, for introducing me. Do we have pointer? Okay, you can use the mouse. Okay. So, good afternoon, friends. In this post-lunch session, which talks about the basics of microcontroller, which is a computer on a chip. So, is there any board also here? No, maybe it's not there. Anyways, so there are contents like this. In outlines, we will be looking at the comparison of the processors and controller, because whenever we talk about the controller, it is important to understand the processor, and I understand that you all are well versed with the microprocessors. Still, we'll just brush it up, and we'll switch over to the controllers, and that will be very apt way of actually starting with the controller. Then advantages of microcontroller is something that we'll take a look at it, and embedded systems, just a little bit glimpses and brief about the embedded systems, and we will talk about the basics of microcontroller and what is the importance of microcontroller as far as the embedded system is concerned. Is actually it is the brain to the embedded system. So obviously, when we select this kind of controllers, we have to understand what is the selection criteria for choosing a controller. So choosing a microcontroller is one of the important aspects while we deal with the embedded systems, and therefore while we understand the basics, these are the few aspects which I'll be trying to undertake. Then speed and packaging, memory and cost per unit. These are other important attributes as far as the controllers are concerned. In fact, almost any electronic design will have this kind of similar attributes which are of due importance. And controller definitely, as you know, in case of processor, speed is very important attribute to controller. And then packaging, because you see all these controllers, they are used for the development of the embedded system or some applications, real-world applications. And therefore, real-world application, when we talk of real-world applications, all these basically controllers, they have unique characteristics. Why these have been invented and why these existed. It is because of the reason that we need to have a cost effectiveness, space effectiveness, and power efficiency, etc. And that is where the importance of embedded system, and that is where the importance of relevance of the controller is there. So the packaging, that is the footprint size and how compact it is another important attribute and criteria and factor to be considered, which we should be looking into it. Then obviously memory, what are the different types of memories, what are the capacities of memories in different chips available as far as the development are concerned, and then controllers are concerned. Different controllers versions from the different manufacturers, they provide different memory sizes to suit your application. And fortunately, these days, with a lot of advancements, almost all customizations are possible, unlike old days wherein you were restricted to some amount of memory, some amount of timers, counters, etc. But now it's been quite flexible for that matter, and a lot of variety, lot of flexibility, versatility is there in the selection of the controllers. So memory is one of the important thing, and that we'll take a look at it. And different controllers, they offer different memories, different manufacturers, they have different packaging, sizes, memory, availability to suit your applications. There is selection guide also. So we don't have to worry much on this aspect basically, because every manufacturer almost provides you a flexibility of selecting all these attributes. There is a select guide. There is a guide for selection, and which at a glance takes you to complete family. It's not that it's going to take you long to understand it and select it. So you just have to be clear about your application, formulate your specifications that this is what you need, this many IOs, this much of memory. So a rough idea can also help you make a right selection. And further, you can fine tune the things. Then cost per unit, obviously, even a 1 rupee can make a big difference if there is a sale of 1 lakh pieces or 1 crores of particular product, then around 1 crore. So, I mean, cost will matter a lot. Even 10 paisa change or 20 paisa, 1 rupees, that all matters. And especially, recent, I mean, these days, most of the things are available from the Chinese manufacturers. And China has been a hub as far as the manufacturing is concerned. And so, as a design engineer, as an embedded engineer, selection of the controller matters a lot as far as the cost goes. Small difference will make a big difference actually as far as the product developments are concerned. So cost will definitely play a role, and how all different factors contribute to the cost, etc. That we'll see little bit. Then various members of the controller. There are actually, Intel's launched controller way back in 1970s or so, and since then a lot of things happened, and very wisely they allowed most of the manufacturers to productionize their core, MCS51 core, and other manufacturers definitely added their own features, etc., to make it much more versatile and application specific. So various members of 8051 we will be seeing, and what they offer and how they offer, that will be taking into. Okay, and so let's understand now what is processor and controller, how do they differ, and I think the same design team engineer who invented processors or controller, they are into the helm of affairs, and they started in somewhere in 60s and 70s. And firstly, the processor came into existence. 4004 was a 4-bit microprocessor initially came into picture, launched by Intel's, and then this processor, basically what it consists of is actually arithmetic logic unit for performing the logical and arithmetic operations, as you know. And then there is a control unit, there is a program counter, and obviously this program counter points to the next instruction, and it executes the instruction. Control unit controls and synchronizes all the timing, etc. And while doing so, you need to have some registers. Okay, so accumulator A, B, etc. So these registers are there, and that is what the microprocessor actually consists of. So CPU, we call it as a CPU. Now, the team which actually made these processors also felt a need, when they actually, because see, there is a purpose for everything, and these processors are meant to actually work with the real world, and everything is made to solve problems of the real world. And when you develop any kind of systems, these processors are put at the job, and then what happened was they felt that there is a shortcoming and there is something which is still missing, and you cannot have interaction with the real world. And for interacting with the real world, you need many more things, which was actually missing as far as the processors were concerned. And so they, the very first thing is that when you actually write a program, the very first thing that you need actually the program memory. So that program memory, read-only memory, that is what actually was required. So they added ROM, and obviously when you perform any operations, you need some scratch pad or temporary memories. So they again added the RAM. And not that only, but while interacting with the real world, it's not only the program. Then you need to have ports like your computers. Your general purpose computers, they have all sort of ports, and that is why we are able to actually interact with the control computers, like our day-to-day life. In our day-to-day life, we interact with the computers. There is a mouse, there is a keypad, etc. So there is the input-output port. There are ports which actually interact with the real world, and that is what actually one of the shortcoming they noticed. And so they added another thing, another block to the processor, that was actually the ports. So I/O ports, input-output ports. You can have information inside, and you can have actually actuation or decisions outside. So there is an input and output ports, which was actually further added to the core, and that is how actually it started giving a shape to another core, another family of the devices called as microcontroller. Then in microcontroller again, there were some like ports are there, like parallel ports, which are the connection to the real world, to the processor. But then there are serial ports also required, and there is a lot of difference between serial port and parallel port. Parallel port though have a lot of fastest way of communicating and interacting and transfer of the information, like your printers. But then serial ports can transfer that information to a quite longer distances, like your modems, etc. So this is one of the most popular interface that exists in the real world, that is serial port. Very convenient to use and a lot of merits to it. And therefore they added something like serial port SCI, serial communication interface on chip, the microprocessor. And combining these all blocks, obviously these blocks have been joined with the common bus system, which includes your address bus, and control unit, control bus and data bus. So once they add this all together and join to the CPU, it becomes a microcomputer on a chip. So it is called as microcomputer on a chip because it is as good as now computer, like our day-to-day life, big computer that we operate or laptops that we operate. But it is called now micro because it is on a chip. So a chip on a computer on a chip is called as microcomputer. So that is how basically you can see now on the slide. I hope these slides are visible to you. And you can see that in A, it shows that general purpose microprocessor system, wherein everything, all these logical blocks, RAM, ROM, ports, timers, counters, serial port, etc., they are external to the CPU. So there is a CPU core, and obviously these all blocks are external to it, connected to it. So this kind of system, which can also basically useful or you can find in the real world for developing an embedded systems, but then these are external blocks, and obviously it also gives a lot of flexibility. So this is a complete this is a general purpose processor system, and in which you can clearly see that all these blocks are external to the processor. Whereas microcontroller, you can see that there is a single boundary line, and inside that all boundary line there are all blocks placed inside it, like CPU is there. So within the controller there is a controller there is a processor inbuilt in it. So every controller has got processor inbuilt in it, whereas it is not a vice versa. Reverse is not true. Inside every processor there is no microcontroller, but inside every microcontroller there is a microprocessor in it. So there is a CPU called a CPU, which is microprocessor, and all these blocks which we talked about, which are external to the processor case. So when we put them all together on a single chip, single wafer, silicon wafer, it forms a microcontroller. So that is the major difference between the processor and controller. And obviously now it becomes much more easy. Same design team engineer basically invented it, and obviously cost effectiveness is there, a lot of flexibility is there, customization is all possible, and there are so many things that are available, and there are basically merits and demerits of both the systems. It's not that, but obviously processor controller is much more popular, much more it's more in the use now. In most of the applications you find that is there, all the products, small compact products, etc. Whereas if the systems are very complicated, then people also prefer processors. Now embedded computing systems use a microprocessor or microcontroller to do one task only. Now these are another differences, like it says that microprocessor or microcontroller to do one task only. That is another important difference. Like in general purpose processors, it can do multiple things. Okay, You can do word processing, you can do programming, so many things, in fact, web browsing and all that. Whereas you will not see that a product which is built or designed around microcontroller is doing too many tasks at a time. For example, your elevators, your microwave ovens, your washing machines, though they handle multiple tasks within the task, which is actually dedicated to a particular application or particular intention or objective, but they are not a general purpose things. So that is the major difference. But somehow it has been a kind of theoretical. It has becoming a kind of theoretical language, for the reason that these days the most well-known example of an embedded system and which uses the microcontroller is actually the mobile phones, smartphones. And you can see that this mobile phones, actually they are also considered as a good example of embedded systems, which again uses the microcontroller. But then there has been a lot of kind of debates and deliberations, and it also states very clearly the difference between, actually, because these smartphones are no more actually dedicated to a single task. They can almost allow you for doing the PPTs, word processing, searching, web browsing, so many things, in fact, as good as it is matching your general purpose computer. So there has been a kind of a small thin line between what it understands. So, but still it remains the main definition of microcontroller of or an embedded system is actually the combination of hardware software to perform a dedicated task. It is meant to perform a dedicated task. So what will you call to the smart mobile phones these days? I think I'll leave it to you. Then PC used for any number of applications. As you can see, like we talked about word processing, print server, bank, teller, terminal, video game player, network server, internet terminal, etc. And PC contains or is connected to various embedded products. The computer is also actually is an integration of multiple embedded products. So although combining all together is called as a general purpose processor or a computer, but individually, if you take an example of a mouse, if you take example of hard disk or all CD-ROMs, etc., keypads, they all are actually individually termed as an embedded system products. Inside them, there is a dedicated controller chip inside which understands the signals. Like if you are using the mouse, wherever you click, it understands, it communicates. And so every component of a integrated general purpose computer is actually dedicated and meant to perform single job. Like printers also, they're doing particularly dedicated tasks, modem, disk controllers, and all these. So these are some differences. And in day-to-day life, we are coming across a lot of products which uses these processors and controllers. Starting from whether you are sleeping or you are getting up, you are having breakfast, you are bathing, you are driving, you are in office, everywhere. I think you cannot imagine to have your life without embedded system products. When you sleep, this is a mobile, you put the alarm, or you do so many things, you organize your day, next day, or that night also. Morning you'll get up 6 o'clock, or so you'll do yoga at 6:30 or something like that. You'll program. So everything is like that. When you go to, and when you go to bathroom, washroom, I think there are also so many ready shavers, your geysers which are programmable, your washers, they are programmable, showers programmable. When you come out of washroom, then again I think you are having breakfast or so there are toasters, microwave ovens. And when you get in your car, there is again GPS is there, which is driving you or taking you to the destination. Microprocessor field engine is there, sitting inside the car. When you reach office, there is a printer, fax, so many things basically. And so I think in day-to-day life, a lot of things are there, which includes your microprocessor, microcontroller-based embedded system applications, and obviously these TVs, VCRs, all the smart gadgets, your game controllers, all these are actually, you cannot imagine without having embedded system. So office, all these I think I have covered. So there are a lot of applications basically. I think there is hardly any applications which is not touched by the embedded system and so the microcontroller. and therefore it is all the more important to understand what this control is all about and what are its what is the base. The 8051 that we are talking about is it is the basic and the most initial version of the controller. So computing needs, software development. Okay, then these are another important considerations as we were talking. Computing needs. Whenever we select any kind of controller, I think this is another important aspect and factors which needs due consideration, that your computing needs, which includes the speed, packaging. This you have already go. Okay. I was not aware. Anyways, so how, what basics have you?
Architecture part, pin diagram, program status word.
This is all.
Yeah, this has been covered.
This is done.
Already covered.
Okay.
ये भी हो गया.
Okay.
ये
Anyways, okay. So I'll go to this slide. I think some of the things which are actually common to this have been already covered by Madam. So I'll come over here, which is in which there is something new for sharing with you. So we should study architecture and memory organization, study subsystems that are available in standard versions, and you know, I think this we already discussed in 1980s or so. The American chip manufacturer Intel introduced 8051. Now many other firms are manufacturing compatible versions. The name given to the whole group of microcontrollers is 8051. Actually, there are so many versions: 8051, 8052, etc. 89C51, 89C52, 55, WD, and all those versions. But the common name given is actually MCS51 standard, that is 8051, which uses actually 8-bit core. Okay, let's see the features of the 8051 microcontroller. Okay, so this 8051, Intel's 8051, it is actually 8-bit controller, 8-bit CPU. And unlike your other higher versions, like big controllers uses 32-bit 32 instruction sets, but this 8051 actually uses 111 operating instruction sets, including multiplication and division. So you might be aware that what kind of there are different architectures of the controller, basically CISC and RISC, etc. How many, I don't know if you are aware, how many of you are aware of the architectures CISC and RISC, and then what is this 8051 architecture? What is the architecture of 8051? Are you aware what is the architecture of 8051? Any center would like to respond to that? There are different architectures. Whenever we design any chip, any controller, there is a software architecture, there is a hardware architecture. As far as the hardware architecture is concerned, there is like Harvard architecture, Van Neumann, Princeton architecture, who actually developed the cores of this, and there is a difference. Harvard uses actually two separate data buses, address buses for different memories. And as far as the software architectures are concerned, there is a well-known architecture called as CISC and RISC. CISC is actually the complex instruction set computers, and RISC is actually reduced instruction set computers. So I would like to know from you, if you know that what is the architecture that is used in case of 8051, Intel's 8051. Just I'm asking because I want to keep you awake for this post lunch. So I think it will be good to have interactive session, little bit interactive. So just to keep you awake and just to keep your interest intact, I wish to interact to one of the center, whatever center, you may go ahead and respond to that query, that what kind of architecture is available in case of Intel's 8051. It is CISC. He says one of the students here is saying CISC. Anyone from the remote end? Okay, so I think he's right saying that it is this that is complex instruction set computers. Basically, it uses number of instructions, triple one instructions, and people often misunderstand when they compare RISC and CISC, because RISC says that it is reduced instruction set computers, but its literal meaning is not actually reduced instruction set computers. Reduced meaning not that it is actually less number of instructions, which often people misunderstand, and which is the case with the PIC controllers. Your microchip family PIC controllers, actually they use the RISC architecture, and they use this RISC architecture, and that is actually reduced instruction set computers, and they use somewhere like 32, or actually in that also there are different families. So there is 32 or 33 instruction sets that they use. What actually it means actually is the simple to use and easy to execute the instructions. So simple and easy, and which consumes less bytes and less machine cycles is called as RISC set computers. Whereas this Intel's actually uses CISC, which is actually complex instruction set computers, and which is meaning that actually they use the instructions which are complex, like your addition, subtraction, multiplication, division. So they have different philosophy, that they use the instructions which are complex. So definitely they will not take single 1 byte or 1 machine cycle. They might take 2 byte or 2 machine cycle kind of scenario, and therefore actually definitely it actually loads the CPU, and which is not case with the RISC. In case of RISC, actually the instructions are very easy and simple, and therefore it normally they take 1 machine cycle and 1 byte. So normally within 1 machine cycle they get executed. So 1 cycle and machine cycle and 1 byte, that is the thing that they take. So in case of 8051, it is instruction set of 111 operating, including multiplication and division, and it is Boolean processor. So I hope you understand that it is zeros. It works on zeros and ones, and it's a digital logic, and it's not a mixed signal controller, right? These days there are actually mixed signal controllers as well available in the market, and obviously they belong to the advanced level of controllers, which is not the case with the basic 8051. And 64 kilobytes of program memory, that is the address space it can have. Because that much, program memory is actually something wherein we store the program. We also call it as a read-only memory, because we store the program, we cannot read and we cannot write. So it is only program which is stored in this 64 kilo in this memory. And there is a limitation to this 64 kilo, because it is actually 16-bit address bus. So 2 to the power 16 becomes only 64K. So that much it can actually access, and that much it can store, and that much memory it can actually address to, or it can reach to. So those many memory locations, so it becomes like, I think 64K. So yeah, 65536. That much maximum it can address in decimal. That many memory locations it can address. And similarly, data memory it can have 64K again, and that is actually memory which is a scratch pad, and its temporary memory also is there, and you can it stores your temporary variables. And 8051, its inbuilt memories, this is actually the space maximum it can go, but this is not its capacity. I mean, this is not it actually available to you on chip. This is not the on chip memory available to you. This is maximum it can be extended to, it can accommodate to. So on chip in case of 8051 is 128 bytes of RAM and 4 kilobytes of your ROM, right? So that is what is available to you. So might be some of you might be wondering so far that how come it is 64K, but it is not that. It is that is maximum it can go for. So on chip is available, which is 128 and 4K RAM and ROM respectively. Okay. Now besides this, it has got two 16-bit timers and counters. So basically, although it is 8-bit controller, 8-bit CPU, because that is the maximum, maximum word size, 8-bit bits at a time, simultaneously, parallelly, it can process that 8 bits. But then it has got two 16-bit timers and counters. So obviously, it uses two separate 8-bit registers to actually perform the operations of timers and counter, Tmod, Tcon, like that, TL, TH, high registers and low registers. These two registers it uses for actually performing the operations of the timers counters. Besides now, any controller, and as you know that was the major difference between a processor and the controller, that controller provides you this real world interaction, real world interfacing, real world handshaking through its ports. So what are these ports? These are actually these parallel ports which are available for you, for the user to interact with the real world. So there are 4 ports available in the controller, that is P0, P1, P2, P3. We'll be seeing shortly the pin diagram and all that. So combinedly it makes you actually 8 4s 32. So there are 8 IOs available per port, and they make you they get you 32 IOs available, and which are bidirectional, meaning that you can read and write both, and data can be input, data can be output. So it can come in, it can go out. So they are bidirectional IO lines available to you. These are 32. So depending upon your applications, you can decide about it, that whether you need this kind of, because this is the 40-pin chip. This 8051 is actually 40-pin chip. So you can actually decide about, do you want to have 40-pin chip which consists of 32 bidirectional IO lines, or you can have some 20-bit chips. There are different 20-bit chips also available, wherein you have normally 15 or 14 or 16 IO lines available. So this in case of 8051, however, you have got 40, it is a 40-pin chip, and there are 32 bidirectional IO lines available, which you can program as an input or which you can program as an output depending upon your real-world requirement. Besides, these 32 bidirectional IO lines, these 4 ports that we talked about, these are actually the parallel ports. And as I said, parallel ports, they definitely give you very high speed communication, and there are, besides other advantages, merits, but then so far as the long distance communication is concerned, and most popular interface in the real world as far as the communication goes is actually the serial port. And controller, as you know, it is a computer on a chip, microcomputer on a chip. It almost is giving you, making you available everything that is normally available to the computer, general purpose computer otherwise. So one of the important aspect is also having a serial port. So again, this is a full duplex serial port, meaning that actually duplex, there are actually simplex and duplex. This is a full duplex serial port, and obviously, since it is a full duplex serial port, you are actually able to simultaneously transmit as well as receive the data. Since it is a duplex, had it been simplex, it would have not been the case. But then there are different types of communications, simplex, duplex, and asynchronous, synchronous, etc. So this provides you actually full duplex serial port, which can enable you to have transmission as well as reception at the same time, because independently 2 pins are available. There is a transmit pin available, there is a receive pin available, and these 2 pins are independent, hardwired, and so therefore simultaneously it can perform both the jobs, transmission as well as the reception. Basically this is hardware-based serial port. There is inside it there is a UART, universal asynchronous receiver transmitter. So there is an inbuilt, there is on-chip SCI, serial communication interface, which is on chip on this 8051, which consists of the UART. And as you know, this is actually also possible to make it using the software. So through software also you can actually create the UART and all this, but then it may not be that precise and that accurate and that fast or as accurate as this can be. So this is a hardware-based full duplex serial port which is available on chip, the microcontroller port, microcontroller hardware. So this is actually taking care of your serial port. So as far as the communications are concerned, you can have parallel communication, you can have serial communication, and in real world, as you see now, you might be in need of actually counting the pulses, or you might need to count the frequency, or you might need to count pulse width modulation, etc. kind of situations, or you might need to count or sense kind of sensors or encoders which actually have different type of pulses. So what you need is actually the timers and counters. So these timers and counters, these counters actually count the pulses or frequency counters, and at many times you need to generate the precision delays, precise delays, accurate delays. There are different methods, vector, and different. But those are software. Software, you can write for loops or while loops, but then those software-based delays are not as accurate as these hardware delay timers are there. So timers are normally used for generating the precise time delay generations, and they are also actually they're actually the counters also. They are used for the counting purposes. When they count the pulses, actually they generate different timings, etc. So they are very useful for actually addressing your real-world requirements, frequency counters or so, and 32-bit IOs, which you can actually interface to any of your real-world requirement. You might connect your GPS, printer, or LCDs, keypads, or memory. Anything can be interfaced with this kind of 32 IOs. And full duplex serial port, either that can be used for actually communicating with the computer or any other similar compatible devices, as well as this can be also used for interfacing your GPS. These days actually most of the GPS, they have serial port kind of communications availability. Even most of the devices, even LCDs these days are available on SPS, serial peripheral interface kind of controllers. So serial communication is available. Even memories are available on serial communication. So because one of the advantages actually, let's say you might be aware, you might be aware of some interfacing work, like LCD takes 8-bit for interfacing the LCD, but if that LCD is serial port based LCD, then it will use just 2 pins. Okay, so receiver and transmitter. So it will use just 2 pins, and you can save a lot of pins. And this matters actually. We have seen that cost is a very important factor. So therefore, if it is a serial based, it can save a lot of pins. So you can have printer interfacing, GPS interfacing, and many interfaces like that. And as far as the embedded system is concerned, there are a lot of other components which actually matters and which shape up the performance of the embedded systems. So one of the important aspect is actually on-chip clock oscillator. So having an on-chip clock oscillator matters because this is something was not available to the processor. Then it saves the cost. There is a lot of optimization, and without clock, actually nothing can work. All these analog digital chips and blocks cannot work. It is like having a heartbeat. So that heartbeat, with that heartbeat only, every complete hardware actually it receives the timing and all that, it works. So on-chip oscillator is the most important aspect to any controller, and 8051 is having that kind of on-chip oscillator, clock oscillator, and it is also quite possible to supply, input from externally through different sources. There are RC oscillator, there are crystal kind of quartz crystal oscillators. Through any other sources also, you can use the function generators to input the different oscillators. And one of the important information I would like to give you is, what is the maximum and minimum crystal that you can connect? Any idea to you at this moment? Yes. For Atmel or otherwise Intel's also. Yeah, different controllers, but then as far as the NCS 15 or 8051 standards are concerned, and Intel's 8051 is concerned, it is 4 to 30 megahertz and up to 24 megahertz or 30 megahertz, and definitely it matters as far as the lower and higher frequencies are concerned, because it is one of the performance shaping the performance of the embedded system, because any application that you develop, if its speed and performance depends upon the kind of oscillators available. one of the applications that we developed recently uses the 100 megahertz crystal. So you can have, like, if it is one machine cycle, you can have 100 million instruction per second. That is a normal rough estimate of performance of any controller. So 30 megahertz of course will have less speed comparatively, and machine cycle will also have some role to play, because in case of 8051 machine cycle is crystal frequency by 12. So it takes 12 clock pulses to actually perform that job, one machine cycle, and every instruction can have different number of machine cycles and different bytes that they consume, the mnemonics and the instruction depend upon the instruction. So this on-chip clock oscillator has a lot of role and a lot of importance attached to it, that how maximum and how much maximum speed that you can have. Let's say you want to count some pulses or some frequency counter you are developing, and that frequency counter, it is very high speed, that is the pulses are changing very fast. The age, maybe it is age triggered and you are triggering your timers and counters, etc. But your controller itself is not that fast, so it cannot using that sampling theorem. So based on the sampling theorem, it cannot sample all the pulses, so it is not able to perform that job. So therefore on-chip oscillator will play a role, and 8051 can go up to 30 megahertz, and it is actually SRAM, static RAM. I think it has got a static and dynamic RAM. It depends upon what kind of RAM it uses, and therefore that lower limit is there. So that lower limit, why it is not starting from 0? That is one of the question and query that you can ponder upon. Why is not that starting at 0 and it is starting at 4 megahertz? So that has something to do with the advancements. One of the clue is actually with the memories, whether it is SRAM or DRAM, and these different memories, they actually have different requirements. And for that matter, well, one of the information I want to give you is actually any advancement of the controller happen based upon the kind of memory advancements that we have. So if the memories are advancing, then we can have different controllers with the much more better facilities, etc. Whether you consider any controller having in-system programming, in-application programming, or any other like pipelining or this architecture. So it has some linkage with the memory advancements, and that is why this PIC controller or other controllers, Atmel controllers, mixed signal controllers, they have an electrically erasable controllers. So they have different actually memory architectures, and they only lead to this kind of advancements. So the advancement of any controller actually has got a linkage with the advancements in the memory. Okay. Now the 4K bytes, as we already said, actually this is the on-chip program memory. This is factory masked programmable read-only memory. And excuse me. In memories, as you are aware, there are actually different types of memory. SRAM and DRAM, of course, these are there, but then one-time programmable, okay, EPROM, okay, there is something called as PROM, which is programmable read-only memory. And then these PROMs are actually, they are programmable, and there are something called as one-time programmable, which are actually maskable, they are only once programmed and factory programmed, and you cannot reprogram them. And they have attached different importance to all these memory types, because they are cost effective. Like factory mask memories are actually very cost effective because they are programmed from the factory itself, because they are using the final versions. Like all the development is complete, then you can request to the manufacturer that, okay, I need 1,000 pieces or so, and they are factory masked. So they are very cost effective. Whereas in normal consideration, we have actually programmable read-only memories, and then there are something called as EPROMs, electrically programmable read-only memories. So 4 kilobytes on-chip program memory is there in case of 8051, which is factory masked and programmable ROM. And if it is EPROM, you will find those kind of controllers, which is of course not the case with Intel's 8051. You'll find that they are actually having a there is a window to it on the top of it, and they are erased through the UV rays. So those controllers, they have separate. I think the series starts with the 87. So 87 series starts with that kind of memories having inbuilt and they can be erasable. They are programmable and they're erasable also, and they can be erased with the UV sources. So UV source, using UV source, you can erase them, and there are like 8-9 series, which is another series from the ATMEL. So 8-9 stands for the electrically erasable. So these are the factory standards. So wherever you will see that 89, that means the memory is electrically erasable. Just with the flash of it will actually erase, and within few seconds only. So 889051, one of the controller version available from the ATMEL, having this kind of capacity. And this is Intel 8051 is having 4 kilobytes on-chip program memory, which is factory mask programmable ROM, and processes 128 bytes of internal data memory. So for storing your temporary variables, called as normally we call it scratchpad, and there is a 128 bytes of internal RAM. And we'll come for further, and we'll see that how this actually is divided into different banks and how it is used for different purposes, how the stack pointer works, etc. So it has 128 bytes of internal data memory. Excuse me, can I have watch, please? Watch, because I'm unable to keep watch on that. So if I can keep it here, something like anything like that. Okay, yes. Thank you. So I'll be able to manage the time. Okay, so it has got 128, and obviously, as I said, if you want to extend it, then you can obviously go up to the 64K. There are different chips, like in case of 8051, Intel's 8051, you can go for 27C512, which is a ROM, and there is another 62256, which is a RAM, which is extendable. So you can definitely, but you will have to sacrifice 2 ports of the controller. Yeah, and oscillator frequency for most devices actually vary between 3.5 to 24 megahertz. To be precise, and some versions can also run up to the 33 megahertz. And microcontroller unit based on dynamic logic can't operate below a certain clock rate, but static devices are able to slow down to 0. So dynamic RAM based 8051s actually can't operate below 3.5 megahertz. As you can see, that is the limit. Whereas those which are built on the DRAM logic, SRAM logic, they can go as low as 0 megahertz. And well, for 12 megahertz crystal, it will take 1, 2, or 4 microseconds for a given instruction to be executed. Basically, it depends upon the machine cycle, and so 12, that is the crystal divided by 12, actually it gives you 1 microsecond. So that is the time it takes. So 1 machine cycle for executing 1 instruction, it takes that much, and depends upon the type of instruction as well. So whether it takes 2 bytes or 2 machine cycle, but and 8051, the whole instructions are not that optimized. Whereas in case of PIC controller, almost every instruction gets executed in 1 machine cycle only. So almost every instruction is going to take 1 microsecond only. So therefore also it is much more faster. And assuming 1 microsecond instructions are most frequent, it can be viewed as an engine delivering 1 million instruction per second performance. Actually 1 MIPS, and as I said that 1 machine cycle crystal divided by 12, because 12 clock pulses it takes, and there are 6 states in the 12 clock pulses, and 12 phases, and each phase consists of 2 there are 6 states, each state consists of 2 phases. So there are 12 clock pulses which actually are used for executing any instruction. And if we consider that 1 instruction takes 1 machine cycle, it is 1 million instruction per second. But it is very less. And the advanced controllers, actually it is one of the estimate. Why do we see into that? Because there are like dry stone or MIPS. These are the rough estimates. These are the rough estimates of actually the speed and performance of the controller. So as a layman, if you don't know how to know that which controller is very powerful, you can use these kind of estimates. And if as I was telling you that 100 MIPS is considered higher. So one of the controller that we were using, although 8-bit, but it was like 100 MIPS per second, that kind of performance. So you can use that as a rough estimate to know the performance of the controller. The actual performance can be only known by running the particular instruction and kind of some subroutine, and knowing you that okay, this kind of subroutine that effectively or efficiently it can perform. So CMOS, obviously, this all of us know that CMOS versions will draw less power and can operate in idle and powered on mode as well. So when we say that 80C51, actually that C stands for CMOS, okay, and MCS51 is actually the standard. Okay, let's have some look at the architecture, and you can take a look at this slide which says that 8051 actually is an 8-bit microcontroller, meaning that it can process all 8 bits simultaneously. So maximum that much it can do. If it is 16-bit, had it been 16-bit, it would have processed 16 bits at a time. And as you know, it is like the example can be given like it is like lanes. More number of lanes that you have on the roads, like 4-lane, 2-lane systems. So faster will be the information access or processing. So that is how it is, and so 8-bit will have sort of performance which is lesser than the 16-bit controllers. And therefore, most of the registers that are available in the 8051, they are 8-bit registers, and like there are 8-bit register banks, and most like banks are banks. Basically, there are 4 banks available: bank 0 to bank 3, and these 4 banks. We'll see in its memory architecture that how much memory it takes and how the organization is. So, actually they take the 32 bytes of memory from 00 to 2F, and we'll see the memory architecture shortly. And in addition, one 16-bit register is there, data pointer. So this is actually a 16-bit register besides your accumulator, which is a 8-bit. So most of the operations that are happening in 8051 are actually through the accumulator. Okay. Very rarely you'll see that any kind of typical multiplication division operation happening, then only register B comes into picture. Otherwise, all the operations are actually through accumulator. And besides this, if there is like if you are having access with the memory, external memory, then your data pointer DPTR comes into picture, because you have to access the 16-bit of address size, and therefore those address spaces are actually 16-bit wide, and therefore you need the kind of data pointer which is actually 16-bit register, and it is used to address the external data memory. We have seen that this accumulator, and almost all arithmetic operations and data transfer with the external data memory are implemented through accumulator. Register B is involved in multiplication and division, and program status word. You know what happens, like there is a program counter. In any memory, in any embedded system, basically there is what we do is actually we write the program, right? What do we do? Basically, any application there is a program, and where is that program stored? In ROM. That is where it is stored. And who fetches that program? Program counter actually fetching the program. So control unit controls the things. Program counter points to the next address and all that. So this is how the whole instructions are actually getting processed, and program is getting executed for a particular application. Now, while doing so, what happens? ALU and all these are actually handling all the operations. So what happens is actually different status are getting generated of different processes that are happening inside the processor. So who tells us the status of these different processes? What is happening? It is program status word. So whatever the program is doing, whatever the status is happening, so who keeps us the checks on all these processes is actually program status word. So there is something called as PSW, which is again a 8-bit register, and this register actually contains the few flags. So whenever some particular operation happens, there are different flags like carry flag, auxiliary flag, and so it indicates in terms of flagging of those flags, 0 or 1, either 0 or 1, or parity flag, and so on. We'll see through examples how those flags work. So this is all about the architecture of 8051. It has basically program counter, there is accumulator, there is a B register, and there are program status word, and there are timer counters. Nothing more than that. So if you look at it, there is actually RAM, ROM. That is what all it is. and RAM is again actually divided into banks, and in ROM there is your program to take care of all the operations. You need accumulator, you need status word, you need program counter, and in case of additional memory that you want to access to, then you need the data pointer. Okay, then one of the important thing is like architecture is something, it will put everything on chip what is required. Okay, so one of the important thing that you need is actually while executing some operations, it often happens like that somebody is interrupting the things. Some operation is interrupting the ongoing operation. So what happens is that there should be some arrangement available to the processor or controller to take care of these kind of things. So there is something called a stack pointer. Okay, so what that stack pointer does is actually it points to the memory. Okay, it points to the memory and it stores or either stores there or retains from there. So stack pointer does all these jobs. So stack pointer is nothing but it related to the stack operations and is incremented before data is stored. So whether data is stored or retained, so actually it is incremented. So stack pointer क्या करता है कि stack में और stack क्या करता है कि it may reside anywhere in internal RAM. जितना भी internal RAM है 128 bytes का, वो कहीं पर भी retain कर सकता है, depending upon कौन सा memory आपने select किया है, कौन सा bank select किया है. So there are 4 banks. So out of 4 banks जो भी selection होगा, default bank 0 होता है, and your stack pointer default location 07 होता है. So whatever happens is incremented to 08.
By default, the bank is 1.
By default, bank 0. Starting there.
Yeah. For stack, it is 1.
For stack, it is 1. For stack, it is 1. No, stack, by default, you will have bank 0 because all are 0, 0. I'll come to that. I'll show you. I'll show you how it happens. And stack is initialized at 07 hex after a reset. Stack pointer, that is the address of the stack. Okay, 07 hex after reset, and this causes stack to begin at 08 hex because that is 07 is the default and it increments. Okay, and data pointer is a 16-bit register, and we'll see how that stack works and how the banks are selected shortly in a while. And DPTR is a 16-bit register. DPH, DPL, these are, and that can be viewed as a DPH and DPL. So these are 8-bit obviously, and common access to external data memory is based on this data pointer only. So whenever there is an external access, that will happen through this DPTR. And program counter addresses the instructions in the program memory as usual. And amount and type of program memory varies with version because we are addressing the memory. अगर आपका 4K है, 64K है, तो कहाँ तक जाएगा program counter? FF. Okay, all F वहाँ तक जाएगा. 4 times F तक वहाँ तक जाएगा stack pointer. So depending upon the memory. So 4K के केस में कहाँ तक जाएगा? 00 से शुरू हो गया. So if it is a 4K memory, the program counter will go 000 से, this is the first location. And if it is a 4K memory, which is the case of 8051, so where will it go? This one. Okay. Okay. So depending upon the memory, the stack pointer जो है, so depending upon the amount of the type of the program memory will vary, and depending upon that it can point to the different address. Program counter will address to the different instruction in the program memory, and it depends upon the program memory. So 8031 is one of the version that is available, but it lacks the internal program memory. Okay, with the Atmel, this Intel. And all microprocessors, they possess at least 128 bytes of internal data memory. It will not happen that they don't have the internal memory, because at least they will have. Why it is required? Because there are actually general purpose registers and there are special purpose registers. So all these, your program counter, all your timer counter, etc., your ports, these are special function registers, your ports. So therefore 128 bytes you will definitely find. That is always there. Because your ports and your timers, they form a part of the RAM, which is this 128 bytes. So that will be always there. Unlike your 8031, wherein actually you don't have ROM, which is 0 ROM. But 8051 is having a ROM, 4 kilo of ROM. Now, besides this, ports हमने देख लिया. Besides this, there are on-chip peripherals in case of 805. Like आपको in case of real world interfacing आपको timers चाहिए होंगे, counters चाहिए होंगे. So therefore you will have timer counters उसके अंदर है. These are called as IO peripherals which are available on the 8051. Then you will need 4 parallel ports. These are also on-chip peripherals which will have interaction with the real world. You will have serial port. This is again a on-chip peripheral, input-output peripheral. And there is interrupt. You know, interrupt is also very required. So most of the real-world applications, if you want to efficiently develop this kind of application, you will need interrupt. Interrupt-driven applications are the most efficient applications. So all ports are built from output registers P0 to P3 and buffers. They're actually registers and buffers. So I'll show you some architecture of the ports also, how it is built. And port 0 and port 2 interface the external memory. If you want to have external memory, then definitely you are going to sacrifice 2 ports, that is port 0 and port 2. Because on port 0 there is address and data bus which is multiplexed. And on port 2 you are having higher order address byte, that is A8 to A15. Whereas A0 to A7, that is lower order address byte, is multiplexed with the D0 to D7 on port 0. And that can be multiplexed using the latch. There is a latch which holds the address and allows the data and all that kind of thing. So there is a latch which handles this kind of job. And finally, P3 is also P3 is another port which is important because there is a multiple functions, like there are peripherals like serial port, timer, counter. All those pins are available on port 3. Okay. And finally, there is an on-chip oscillator which is available as well. So this was all about the architecture of the 8051. Now we'll see a little bit about, okay. In memory organization, basically it is organized in 2 parts. There is a program memory which is 4 kilobytes, and there is a data memory which is 128 bytes. And this data memory, as I was telling you, that is divided into 2, like general purpose registers and special function registers. Okay, general purpose registers are free to use, whereas special function registers are actually fixed. You can just program it, but you cannot alter its function. If it is meant for timer, counter, and PCON register, SCON register, etc., you cannot alter the function of those registers. Port 0, let's say, is actually having 80 hex address. You cannot alter that. So therefore, in data memory, you will find 2 kind of separations. There is a general purpose register. There are special purpose registers. And program memory, you have 4 kilobytes. Obviously, the address starts with 00 hex, and on chip it is 4 kilobytes, and externally you can have 64. And memory can also be divided into 4 separate address spaces. Program memory is the first memory address space, that is 64 kilo long. 4K, 8K, or more can reside on chip. Okay, depending about the different versions. Basically, as I was telling, that 8051 you can have different versions. Intel's 8051 is having 4K, but then if you go to the other compatible versions from different manufacturers, you can have 4K, 16K, 32K. But they are at the core, they are MCS 51 standard. But only there is advancement and addition of the memory. And then on reset, CPU begins execution from 0, that is origin. This is all about, because the programmer should know that what is the memory organization. Then only you can program it properly. Otherwise, if you write something and your program counter starts with the 00, and you're writing something which is not starting at 00, your every program should start from 00. Because PC is starting from 00. If you are starting something at some other address, it will not work. And otherwise also, if you put something on memory, programmer, it will automatically start the programming with the 00. Then each interrupt is assigned a fixed location in memory. Just again to test whether you are there or you are asleep, I mean, whether you are there or to make you alert, I just want to ask you, how many interrupt sources are there in 8051? 6 or 5? And what are the 6 or 5 interrupts sources in case of 8051?
If you include reset as an interrupt, then it is 6. If you exclude reset, then it is 10.
Okay, he says that if we include the reset, then it is 6. If we include, if we don't include, it is 5. If we include, it is 6. But that is not the case. Any other, I think, from the remote centers, how many interrupt sources are there? How many interrupt sources are there in case of 8051? MIT. Yes, MIT. Yes, sir. MIU Maulana or MIT or Dronacharya group or maybe from NIT Greater Noida. Okay, anyways, I will tell you. There are actually six interrupt sources, as he rightly said, one of the students sitting here. And the only thing is that, and these interrupt sources are actually interrupt 0, interrupt 1, timer 0, timer 1, and then you have got serial communication interface. So, and in serial communication interface, basically transmit and receive. RxD and TXD, both of them are considered as separate interrupt sources. So these are 6 interrupt sources, totally independent. The only thing is that the vector locations of the serial communication interface is same, 0x23, I guess. So that is the same shared by both RxD and TXD, whereas interrupt 0, interrupt 1, they have different 0x03, 0x13, 0x1, 0x0b, 0x1b, and 0x23. These are actually 6, these are the 5 vector locations for the 6 interrupt sources that are available in the 8051. And whenever there is an interrupt, basically the program counter goes to that location, executes, and then comes back. So these are the hardwired interrupt sources, and anything that you develop using this kind of interrupts is bound to have very efficient response. So therefore, I wanted we were talking about the interrupts, and there are 6 interrupt sources. So each interrupt is, as I said, there are fixed locations in memory, and on interrupt what happens is there is service subroutine, interrupt subroutine you can say, which goes to that memory location. For example, in case of interrupt 0, it is 0x03, and interrupt 0, so interrupt service routine will go there, and it is always reserved. There is nothing written, even if you program in ROM, something like that, but these locations are always reserved for this. So interrupt service locations are spaced at 8 bytes interval. You might notice that all this what I said was 0x03, 0x13, 0x0b, 1b, and 23. These are 8 byte intervals. So if you add 8 to the 3, then it becomes b. So that is the interrupt location for interrupt timer 0, like that. So they are 8 byte intervals. Then memory organization microcontroller can execute instructions either from it or from external memory. So you know, you will find that there is a EA pin, which I'll show in my diagram also. So if this EA pin is connected to the external, like ground, then actually it is using the external memory, and it is connected to the VCC, it is using the on-chip memory. So external data memory is the next second memory address space, and it can have 64 kilobytes of data memory, and memory is addressed indirectly through DPTR, R0 or R1. And there is internal data memory, has size of 256 bytes. It is divided into 2 blocks, 128 bytes for general purpose RAM, 00 to 7FX, and another 128 bytes for 80X to FFX. This SFR area, special function registration area, and thus A, B, program status word, stack pointer, and DPTR plus all other control and status registers are viewed as an internal data memory. Okay, and therefore, in fact, any controller will have minimum at least 128 bytes of memory. And more on the internal data memory, that it has size of 256 bytes, actually, but we call it 128 bytes because few are reserved, and SFRs are organized as an extension of the internal RAM, and 8051 integrates peripheral devices, does need control and status registers, whatever peripheral like timers, counters. To control these timers, counters, serial communication interface, it needs registers like PCON, TCON, there are different registers, and to save these registers, it needs a memory in the internal RAM, so they are stored in the SFR area. Logically, all microcontrollers, registers, general purpose and embedded peripherals are placed in a common group. So lowest 32 bytes are grouped in 4 banks of 8 registers each, R0 to R7. I'll show you graphically also how they are organized. And then there are 2 bits in program status word which selects the banks. Okay, this is about the program status word and how it selects the banks. So you can see, you can observe that the bit 0 D0 is actually the parity flag, and this bit 1 is reserved, and 2 is actually overflow flag, and RS0 and RS1 actually register select. This RS0 and RS1 are used for register select. So you can select or switch the bank, bank 0, bank 1, bank 2, bank 3. And F0 is a general purpose flag, and there is an auxiliary flag. Whenever there is a carry generated from D0 to D3 to D4, there is an auxiliary carry which gets generated, and whenever there is a carry beyond D7 bit, the carry flag gets generated. And depending upon the number of ones available in the operation, we call it parity. The parity flag gets generated. If ones are odd, then we have odd parity, and if ones are even, then we have even parity. Okay, this is something. Okay, so microcontroller can address bit as well as byte. Bit addressable, there is a bit addressable area beyond 20 hex, or in fact 3F. After here 3F, we'll see it in the RAM organization. Beyond that particular space, it is a bit addressable area, and many of the special function registers like PCON, TCON, etc., they are bit addressable. You can say that timer run 0 equal to 0, 1. So every individual bit is addressable. So that is called as bit addressability. Or you can have byte addressability. For example, on port 0, you are writing something, so you can directly write on all the 8 bits. So P0. So on all the 8 bits, so 1 byte can be directly written on the port 0 or port 1 or something like that. And or also you can these all bits these ports are actually bit addressable. So these are bit and byte addressability of the controller. In data memory, from 20 to 2F hex, this 128 bit is actually bit addressable area, and from up to 1F hex, actually that is a bank area, 00 to 1F, and from 20 to 2F hex, that is a bit addressable area, scratch pad you can say. And bit addressable LSB, that is the same thing actually. Marked SFRs are also bit addressable, and we'll see it in the actually now diagram. That will be more clear from there. Well, these are the 4 address spaces, they say: program memory, internal and external. Okay, this picture, I don't know how clear it is, but what I can say, or you can see here, is actually there are 4 banks, and from 00 to 1F hex, there are 4 banks, and each bank is actually 8 byte wide. So in each bank there are 8 registers, R0 to R7, R0 to R7. So you can see on the blackboard also, I can draw it.
Hello. Hello, sir. This is from MIT Meerut. We
Yes,
are
yes.
unable to listen you.
Oh, yes, yes, we got
Uh,
it, and we are just connecting it.
yes, sir.
Just
Now we
right.
can listen.
Yeah, right away we'll
Yes.
connect.
Now it's okay.
Yeah, it's connected, I guess. So there are 4 banks, and each bank is actually 8 byte wide, and each bank consists of 8 registers R0 to R7, and each. So there are basically 4 banks, and 4 banks they are 32 byte wide. So 00 to 1F is actually the bank area, and R0 to R7 these are the 8 registers used, and the selection of the bank depends upon the program status word, those bits that we use, and these are programmable. And 20 to 2F, that is the bit addressable area that we can use. And from 80 to 8F, now you can see that 32 plus this 20 to 2F, this plus 15, and so remaining area from 2F to 2F to 80, and then 80 to F0, that is the area which is actually used for the special function registers. And you can see there are different special function registers here. There is a port 0, there is a stack pointer, DPL, DPH, PCON, that is power control register, TCON, timer control register, TMOD, timer mode register, and then we have SCON, serial control register, SBuffer, and port 2, and they have different addresses, as you can see. Interrupt enable, there are different registers which are stored inside this RAM area, which is 128 bytes long. And this figure is actually not very clear, but whether bit addressable or byte addressable, everything is there. And some of the registers are actually bit addressable, like SCON. SCON is a serial control register, which is a bit addressable register. So whatever star marked are there, these are actually bit addressable. All ports are bit addressable for that matter. And TCON, SCON, interrupt enable, program status word, accumulator, B register, these are all bit addressable registers. And you can see this pin diagram here now, that what we have learned about the architecture of the 8051. The same thing it shows. There is a port 0. There is a port 0 on right side, which is bidirectional. There is a port 1 on the left side. Okay. And there is a port 3. There is a port 2 again coming to the right side, which is 8-bit. So port 0, 1, port 2, and port 3. These are the 4 ports which are 8 bits wide, and these all 4 ports are bidirectional, and that gives you actually 32 IO lines, programmable IO lines. You can program them as input or output, and you can see that this port 0 is actually multiplexed, having address and data lines multiplexed to it. So D0 to D7, because you can actually write or read, so actually the direction is given on the both side. So this is connect, and this has something to do with the read and write operations, because these are the read and write operations when you are having external memory interfacing. So there is a lot of connection here. So we'll just try to understand what is this port 0 and port 2 first, because this port 0 and port 2 are used for external memory interfacing. Let's say the internal memory is not sufficient enough to meet your requirements, then this port 0 and port 2 is something that you will have to sacrifice with. So these 2 ports are getting sacrificed, because you will connect these 8 pins of the port 0, which will give data lines D0 to D7 to the RAM or ROM either, or both. And lower order address byte A0 to A7 is again coming from the same port, that is port 0. So that is going to the again RAM or ROM, and you see that this EA bar, when you this EA bar external access, when you connect this to the ground, so that the signal is coming inside. You can say that the signal is going inside. This logic goes inside, the EA pin goes to the ground, then this is actually the external interfacing. The memory is accessed from the outside, so external access it meaning, and if it is internal memory, then it is connected to the VCC plus 5 volt, so meaning that the on-chip code is executed. So let us understand firstly this external memory access, wherein the EA pin gets, that is pin number 31, is connected to ground, and address latch enable is actually connected to the ROM, and that address is enabled of the ROM, and therefore the codes are being fetched. On the program store enable pin is again connected to the ROM. So this ALE, PSEN, the signals are going out because ALE will give the enable pulse, address latch enable pulse to the ROM, and program store enable will actually give again the pulse for fetching the codes from the memory, ROM memory. So it will enable the program, and on this ALE pulse actually the code gets fetched from the memory. So therefore these are giving actually the external signal. So data, whether now in case of ROM, it is going to be the data here, this instructions here based. So and this port 2 will supply the higher order address byte to the memory with the read or write operation. So A8 to A15, it is going to this port 2. So now, and this D0 to D7, because this write and read operation will happen in case of RAM, because you can read and write both in case of RAM. So it is actually going to this D0 to D7. So WR bar and RD bar, these are the two things which are connected to the RAM, whereas ALE, PSEN, this is connected to the ROM. And on pin number 18 and 19, so basically besides now ports, port 0, port 2, port 1 and port 2 and port 3, besides these 4 ports, what your controller needs is actually the power. In its basic form, in its basic configuration, it will need VCC, that is connected on port pin number 40, and on pin number 20 there is a ground. So in its basic configuration, it will essentially need the power, that is on port pin number 40 and pin number 20, and it will also essentially need the this oscillation, that means crystal. So on pin number 18 and 19, there will be an oscillator connected in its basic requirement, the most basic configuration. So as soon as you give the power, you give the crystal and reset circuit. So at pin number 9, that is RST, you will connect the reset circuit either on chip, or there is a RC circuit also available for giving the reset pulse. There is a difference between the reset pulse of the microcontroller and microprocessor. In case of microcontroller, the reset pulse is active high. In case of microprocessor, it is active low. So as soon as you now give the power and the oscillator circuit on pin number 18, 19 and the reset circuit, the controller is ready to work. It is now ready in its most basic configuration, and now you can do all your interfacing or any other things. So it is ready to interact with the external world. So that is the basic configuration. And so we have seen that port 0 and port 2 are actually play role, take part in as far as the external memory access is concerned, and in that case we are actually sacrificing these 2 ports at the cost of gaining more memory. And in those cases of external memory access, this EA pin, ALE pin, PSEN pin, which are available on pin number 29, 30 and 31, and this 16, 17 stop signals, WR bar and RD bar, play the role. So these are the pins which are useful for actually interfacing the external memory. So you can see all these pins are getting engaged when you do the external access of the memory. Now what you are left out with is actually the port 1 and port 3. So port 1 is completely as such, it is available to you. It is not a dual purpose and it can be completely used. Whereas again port 3 is multi-purpose. It can be used as a input I/O bits, bidirectional I/O bits, as well as if you need some kind of on-chip peripherals interfacing or its application like serial communication interface, so RxD, TxD, because you are receiving, so this arrow will come inside, and if you are transmitting, the arrow will go outside, so signal is going out. So the serial port, you will use these pins, pin number 10 and 11 of the controller. In case if you are using the interrupts, so there are interrupts, interrupt 0 and interrupt 1. These are the external interrupts. Mind it that you can also use the interrupts using the timers or counters which are available on pin number this T0 and T1, that is for pin number 14 and 15 of the controller. These are T0, T1 can be internally generated also. These are the interrupts which can be generated internally. So this transmit receiving can also lead to the interrupts. Whereas if you want to have dedicated interrupts and the external interrupts driven from something like sensors, something is coming, so you can connect them to pin number 12 and 13, interrupt 0 and interrupt 1. So these are the dedicated interrupts. And whereas for any timer, counter, overflow flag gets generated, and that overflow flag generation can be used as a timer, as an interrupt. And similarly is the case with the receiving and transmission. When the transmission happens completely, or the particular flag gets generated, the buffer, there is a particular flag for transmission, there is a particular flag for reception. So as buffer is the register used, and then they combinedly can be used for initiating the interrupts. So port 3 is again a dual purpose kind of port, which is can be used for both the purposes, like IO bits, in general purpose IO bits, or the special function registers, or the special IO peripherals. So this is what this pin diagram and the complete 8051 looks like. It is a 40 pin chip. You can see, note here, there are 1 to 20 on one side, and there are 21 to 40 on other side. So this is a 40 pin chip, and 4 ports, they actually use the 32 IO bits, and then remaining are the 8 pins. Out of them, 2 pins are meant for power, and then 2 pins are meant for crystal. So now remaining 4 pins, these are actually meant for there is one reset, and then there are 3 pins left which are used for the external memory access, that is EA, ALE and PSN. So that is the whole organization of the pin count and its particular application. So the same is written here, how it is used. This is a port 3, which is a dual purpose. Reset is active high. This is said here. Okay, solve we have already covered. This is the timing diagram, how the memory reads. This is a 12 pulses machine cycle frequency oscillators. So there are 6 states in each machine cycle. In each 6 states there are actually 2 phases, phase 1 and phase 2. And this on this ALE pin and PSEN pin, particular instruction and the data gets fetched. This is how the whole memory execution happens. Okay. Yeah, I think Wednesday I have one more lecture, expert lecture. So in that I think some of the part can be again covered, but most of the things, the basic architecture is actually covered already. We are done with that, and I think
rest of the I think part can be carried over when the expert lecture is on Wednesday also. So this is the end of this lecture. So let us talk to the various centers in case they have any doubts. Firstly, we go to NIT Greater Noida. Any doubts?
Hello.
Yes, sir.
No doubts, ma'am. Thank you.
Thank you for patient listening, and I can see a lot of smiles over there. So it's good to have patient and good audience like you.
Next group is Dronacharya Group of Institutions. अरे यहाँ पे लिस्ट रखी हुई थी वो कहाँ गई? इसमें पूरा नाम नहीं है, उसमें कंफ्यूजन है कि एक ग्रेटर नोएडा एक.
हेलो.
अच्छा. Yes.
Good evening, ma'am. Good evening, sir.
Good evening, ma'am.
Sir, I'm from Dronacharya Group of Institutions, Greater Noida.
Yes, ma'am.
So my question is, what is the use of PCON, TCON, SCON registers?
Okay, very good question. And a TCON is meant for timer control register. Okay, madam. So TCON I do have, but I'm not covering the timer counters. But TCON is used for timer control register. Okay. If I have just, I will show you how it looks like. Because since you asked the query, so I think it will be worth showing you all that. It's there and very nicely given actually. Uh, Timer control, so interrupts, so it must be here, interrupts, okay, and timers are there or not, I don't know, but,
Actually,
okay.
I'll be covering the timers part.
But it is a timer control register, okay, TCON, and and second one is actually this is here it is timer control registers. So I wanted to show you how it looks like. So I was just looking at its. This is how. This is actually timer zero register, and we have for controlling the timers. The timer control register is used. Where is that? Tmod is down. TCON. Can you see that TCON there on the slide? There is a timer
Yes.
control register. Madam, can you see that TCON
Yes,
on the
sir.
right side of the slide?
Yes, sir, I can see it.
Yeah, and there are different bits there. Timer 0, TR0, TR1, timer overflow flag, timer overflow flag 1. Because we have timers in, because we have timer 0, we have timer 1. So there are two flags here for timer 0, timer 1. So and they are independent of each other. So therefore each bit, like for timer 0, there is timer 0 run bit or stop bit, and the same bit is used for run and stop, so TR0. And for timer 1 there is a TR1 which can be used for run and stop. And each these timers counters, they generate overflow flags, so they are actually separate independent overflow flags, TF0 and TF1. So TCON is actually used for controlling the operation of the timer, timer 0, timer 1, and second you said SCON, right?
Yes, sir.
Yeah. So second is SCON, and that is actually serial control register. And I'll again be interested in showing you how it looks like. So SCON is again a serial control register, and let me check if I have how it looks like. So it controls actually the operation of the serial operation. For a serial communication, so there is a serial control register. There is a S buffer. Okay, there are for actually controlling the serial operation, you have 2-3 registers like S buffer and SCON. So SCON is actually, S stands for serial and CON stands for control. So serial control register. It is again a 8-bit register, and that is bit addressability is there. I hope I have answered your question. And these to control these peripherals, internal peripherals, actually these registers are used. And here is actually I could find that SCON, and I think let me show you.
Serial communication.
So it is for serial communication. Figure 2. Okay, and these are the different bits. Okay, these are the different bits available in SCON. Okay, so for example, TI, set TI, transmit interrupt. Okay, RI is the receive interrupt. REN is the enable reception of all the modes. So these are the different bits that you will find, and in that SCON register. So SCON register is used for controlling the operation of the, and here you can see, just have a look at this slide which is displayed here, and this is again an 8-bit register, and wherever you see that there is a square, a completely filled square, and this dot, that is a bit addressable. It can be addressed with software and hardware both. So it can be controlled by software and hardware both. So you can see it can be set or reset by hardware and software both. So those are marked by those square blocks and round blocks. And this serial control register consists of again 8 bits. So starting with D0, first LSB, that is receive interrupt, transmit interrupt, RB8, TB8, receive enable, SM2, SM1, and SM0. So SM0 and SM1 is used for actually controlling the modes. So I think this is what. Just I think I hope your answer, your query is answered.
Yes, sir. Thank you, sir.
Okay, next we move to the next center, Meerut Institute of Engineering and Technology.
Good afternoon.
Good
This is Varun Kumar Singhal from MIT. Sir, I want to know that you have mentioned one general purpose flag bit in program status word register. Can user use it?
General purpose flag bit.
Yes.
That is not defined. That we do not use that.
It is not allowed to use through
No,
program.
that is for future use. That's
Future
not
use.
used.
That is not. That is meant for future use.
Okay, sir. Thank you.
MMU Mulana.
No doubt, ma'am.
No queries.
Hello.
Dronacharya Group,
No query,
Gurgaon.
ma'am.
Dronacharya Group of Institutions, Gurgaon.
Yeah, can you hear us?
Hello.
Yes, ma'am.
Ma'am, can you elaborate PSEN pin?
PSEN, Program Store Enables.
Yeah, program store enable pin actually on RAM and ROM in case of read-only memory. So there is a for enabling the program which is stored in the ROM, because there are different instructions and program is stored at different locations. So to enable the program which is stored into that ROM, this PSEN from the 8051 is connected to the ROM. So there is a complete synchronization. So PSN is connected to the ROM, which enables the program which is stored into the ROM, and it is fetched on different ALE. That timing diagram I showed you. So there is,
In pin diagram.
yeah, in pin diagram also it was shown. So in pin diagram, I think this we have understood here that PSEN is actually connected to the ROM. So these actually EA, ALE and PSEN, WR bar, RD bar, these tropes, these signals are meant for external memory addressing or accessing.
In simpler words, I will tell you. Let's say there are two things. One is you're using the on-chip memory, or either you're using external memory. So both EA and PSEN are used for the same purpose. In case you are using inbuilt memory, then your EA is connected to the ground. Similarly, this PSEN pin is used in case you are using external memory. But the only difference is that in case you are using on-chip memory of 8051, you do not do anything to PSEN. However, you cannot leave external access pin, which is pin number 31, unconnected. Either you have to connect it to the ground or you have to connect it to the VCC. So both of these are in case you are using external memory interfacing, PSEN pin as well.
Okay,
Whereas
thank you.
you will use EA either on your VCC or on ground. However, in case you are not using external memory, you are using on-chip memory itself, you will not do anything to the PSEN pin. Program store enable pin. I hope that clears your query.
Thank you, ma'am.
Okay.
Thank you, madam.
Any doubts here, our participants? No doubts?
So you said stack pointer is initialized at 07H after reset.
Yes.
Yes.
And it shows that the first location of the stack is at 08.
Yes.
08.
But it is different in case of microprocessor.
Yes.
Yes.
The query is that because in case of whenever we reset the microcontroller, the stack pointer is initialized at 07. Why is it so? And in case of a microprocessor, it is different. I will answer that. Actually, what happens is that the first position of your stack is 08. Whenever you perform any push or pop instruction in case of a microcontroller, this stack pointer is incremented by 1, and then it happens. So whenever, if in case your stack pointer is 07, so whenever you will perform a push instruction, it will be automatically incremented by 1 and it will point to the beginning of your stack. That is why the stack pointer is 07.
So definition for the processor and for the controller.
It is different. It is different. In this case, it is incremented by 1.
It's clear now.
Okay, any other doubts? Okay, so thanks a lot to all the centers for your patience listening, and we have come to the end of this session. Tomorrow again we will be starting with 8051C programs, and we'll be doing more programs as well as the practice. We're doing some practice also on the, and I'll be giving you some questions so that you try them yourself. In the meanwhile, I'll request all the coordinators to kindly download C51 version of Keel. As I told you, please download C51 version of the Keel, as we will be practicing these programs on Keel also.
Yeah, we already done